Hi, everybody.
Hello.
Hey, Adam.
Hi, Thomas. Good to see you again.
Yeah, well, we hosted a year ago, and here we are back together again. Great to be here.
Yes, another BSD themed live stream, I would say.
Yeah. So, yeah, I guess both of us have got a lot of interest in many different topics that overlap. So, yeah, it's cool. So here we are in the second live stream of 4 for Posette 2026, and there's a really exciting lineup of talks to run through. So yeah, it'll be great to we can see here there's 4 different live streams, and there's one that's finished already, but you can catch that in the by going to posetteconf.com. And we have today's live stream, which has a whole 11 really cool talks to watch, and then 2 further streams, and all of those you can catch up with later if you missed it.
And unlike last year, all of the talks are available right after the live stream is finished. So roughly half an hour after we end the live stream, you should be able to go to the schedule page of that you can see linked here of the conference itself. And if you go into individual talks, their YouTube videos should already be available for rewatch if you missed the live stream for any reason. Okay, and hosting for you this year is my colleague Thomas Munro. Thomas has over a decade of experience working on PostgreSQL, parallel query, IO, and other stuff. He's also a FreeBSD committer, as I know, doing a lot with ZFS and PostgreSQL on ZFS. I remember you had a full wiki page on things that would be nice hacking projects to do on to get this going.
Yeah. Cool. And I should introduce you then, my colleague Adam, who is a technical program manager at Microsoft, who's also been working with databases for over a decade and has a really interesting background in info security. And in his spare time, he works on OpenBSD. So coincidentally, we're both BSD hackers in our spare time. But yeah.
Well, I'm more of a slacker now, but yeah, it's happened in the past.
Cool. All right. So, the idea of Posette is to recreate, on the net, some of the experience of a conference where you can collaborate with people and get to know people and, watch a whole lot of really interesting talks. And, that's what we're going to be trying to do in this second live stream.
And what I like about this conference is we are very friendly to first-time speakers. So if you're worried that travel adds to your nervousness or stage fright before doing your first talk, this is a nice place to break that ice and have some of the stress regarding conferences removed, like at least travel logistics. So be sure to, if you missed the CFP this year, be sure to submit for next year.
Yeah, watch out for those dates. Cool. So the Posette conference is put together by the Postgres team at Microsoft, which we're part of. And this year, AMD has partnered with Microsoft to fund this conference, which is fantastic. So,
yeah, very happy to see companies contributing back into the community.
Yeah, so a huge thank you to AMD for partnering with us.
Thank you. So in this event, like in all the previous years, we have a code of conduct. You can scan the QR code to get access to it. But in very short, be friendly and welcoming, be patient, be thoughtful, respectful and inclusive, be open and curious. And if anything happens during the conference, please feel free to reach out to any of us on Discord. or in any other means that you find necessary, and we will act on your requests.
Cool. So during the live stream, there will be captions, automatically rendered captions in English. If you watch the recorded versions later, then you can use 16 different languages with automatic translation. So
yeah, and the captions, the English captions that will be there for the recorded talks are actually vetted and verified by the team, so they are like high quality captions.
oh, cool! So people get a chance to fix little mistakes.
Yes, yes. I remember from like the past years, we went through all the various words that are very hard to sometimes decipher by the automatic translations, and it makes a difference, I believe.
Cool. So enormous thank you to all of the speakers. I think it must be 44, is that right? Different speakers have contributed to this year's Posette.
Yes,
so obviously
there's
without
44
them,
talks, yes.
Yeah. It's a huge number of people who've done a lot of work to bring interesting content and educational content about things that they care about. So thank you to them.
And many more that submitted the papers and maybe didn't make it this year, but we appreciate every submission, and we do hope that you get in the next time around.
Cool. So if you want to see the guide with a bit of a description of each of the talks and get some idea of what there is, because it's so much content, there's a really handy ultimate guide, which you can find here with the URL on the slide there, aka.ms/posette-guide, and there's a QR code there as well. So check that out.
Always handy, yep. So what these talks are about, you can see this nice infographic. The talks are actually split into 4 sections, tagged. You can actually use the guide to drill down to those specific things that you find interesting. So maybe you want to figure out more on stuff that Thomas worked on, like async IO for PostgreSQL. So you can go into the PostgreSQL core tags, core talks, and filter down to async IO and figure out what would be relevant.
Cool. So you can jump onto the Discord channel while the talks are running. So that's kind of the idea with these live streams, rather than just doing everything as recordings. In most cases, or at least many cases, the speakers might be online and you can ask questions directly. And even if not, you can talk to other people who are watching the talk and ask questions that other people might be able to answer, potentially even the speaker in some cases, which recreates the sort of virtual hallway track, as they say, at physical conferences.
Always the best track. And if you have any questions for the speakers, like Thomas mentioned, find us on Discord. Most speakers try to be around at least for their talk, and often throughout the whole event. You can also get some pretty good swag. Like we always come for the socks. So be sure to vote on talks, but also take surveys and track the Discord to get more info on how you can get a pair of these socks.
They're very comfortable. You should definitely do that. At physical conferences, you have those tables where everyone hands out stickers and so on. We have that too. And if you follow these links, you can have packs of a bunch of interesting stickers and other bits and pieces sent to you. But you should also fill in the survey.
Okay. If you're live posting the event, please use the appropriate tagging. We can find us on many platforms. And maybe let's look at the schedule for today's sessions, Thomas.
Cool.
So we have 11 talks. We will be going over them one by one. I'm seeing some familiar faces from last year. maybe let's go over the Livestream trailer. It will do a much better job at quickly giving us an overview of what's coming.
In this keynote panel, we're going to be talking about what actually happens as we approach the annual Postgres feature freeze.
You'll get the inside scoop on how Postgres contributors develop all of your favorite features coming in Postgres 19.
Why do some Postgres patches make the cut while others miss the boat, or even get reverted in the end?
Join us to hear from 4 experienced Postgres hackers and committers who have had years of fun with Postgres and experience with patches both making it and missing the boat.
Hello everyone, I'm Marco Slot, and my talk is going to be about PG Lake, which is an open source extension for connecting Postgres to the wonderful world of data lakes and lakehouses. So I'm going to talk about how you can use PG Lake to import, query, export data in object stores and use it for fast analytics using table formats like Iceberg and file formats like Parquet.
Hi, my name is Adithya Kumaranchath. I'm a principal engineering architect in the Azure Data product group. So my talk is going to be about migrating very large Oracle databases to Azure database for PostgreSQL. So if you're a decision maker or if you're looking to migrate to Azure Postgres, then this talk might be interesting for you.
Hi everyone, my name is Richard Yen. I'm here to talk about PT Stats and about how Postgres and statistics work internally. It's a talk that's geared towards beginner and intermediate users, people who want to get an idea of how Postgres internal statistics operate and how it influences the query planner and how to improve their performance on some of their queries.
Hi, I'm Xuneng. In this talk, I will share a practical path for getting started with Postgres hacking. And we will look at why Postgres hacking feels differently and how to start small and how small compounds over time. If you are interested in Postgres hacking, then this talk is for you.
Hello, this is Murat Tuncer. I'm going to talk about PostgreSQL authentication, that is from trusted tokens and short history of PostgreSQL authentication. It is about how PostgreSQL authenticates your connection. I'm not going to rank methods, I'm just going to explain why each authentication method exists and how you can choose between them.
Hi, this is Gülçin Yıldırım Jelínek. I do product at Zeta. Today we will talk about what's new in Postgres 18 with constraints. I read all the change log, so you don't need to go through it yourself. And the talk is for everyone who is interested in constraints and app development with Postgres and into also database internals. I hope you will enjoy it.
Hi, I'm Alexander Kukushkin, principal engineer at Microsoft. Today I'll talk about PGQ, Postgres extension implementing queue that has been around for almost 20 years. I'll explain why it outperforms keep lock-based design and how to use PGQ on cloud-based Postgres.
The title of this talk is Fast Car Need Fast Brakes. I guess that's the whole point in one sentence. In our industry, people, tend to go faster. They do want to do things faster, but nobody really talk about brakes. Nobody really talk about the safety mechanism that needs to be built around, getting it faster. And in this talk, I'm going to talk about how to build your safety mechanism when you're building your AI solution.
Hi, my name is Josef, and I want to discuss scaling Postgres multi-process architecture, because it's not just about throwing more hardware at the problem. Each connection carries some hidden tags, and it could be Linux level memory and CPU overhead or Postgres level MVCC and locking constraints. So to manage high performance workloads, we need to understand these limits. So join me for a deep dive into these topics, because we shall stop guessing and start tuning our systems.
Hi everyone, I'm Paolo Machytka, and today I'm talking to you about the Postgres generated column. I'm doing that using some example and using Django ORM and some beautiful picture from Italy to show you how to use this fantastic feature from Postgres and Django.
Wow, I'm feeling energized already.
Yeah.
This is a great lineup.
So many
I don't know, what time is it for you, Thomas? Like, my coffee started working. I imagine it's a bit late for you, or the other way around.
It's just after 6 p.m. It's fine.
Nice.
there have been many worse time zones for these things than this.
So you don't need coffee. Great.
No.
I
do
think
have one
we
just
will-
in case.
Okay, cool. Okay, so we will start with the keynote on PostgreSQL 19, what's new, what's out, what's next, with Álvaro, Heikki, Melanie, and you, Thomas.
Yeah.
Maybe you will give us some highlights before we dig into this one.
Well, I don't want to spoil the surprises too much, but yeah, we had a good chat about the difficulty of getting patches into Postgres, and which often involves disappointment and trying again next year. It's a difficult process, and yeah, we had a bit of a friendly chat about how that goes and how that went this year. So
I'm looking forward to it.
In this keynote panel, we're going to be talking about what actually happens as we approach the annual Postgres feature freeze.
You'll get the inside scoop on how Postgres contributors develop all of your favorite features coming in Postgres 19.
Why do some Postgres patches make the cut while others miss the boat, or even get reverted in the end?
Join us to hear from 4 experienced Postgres hackers and committers who have had years of fun with Postgres and experience with patches both making it and missing the boat. So the Postgres 19 development cycle is now behind us. We have entered the feature freeze. Because what we have still left for 19 is going to be betas and alphas and whatever, and lots of testing and so forth. So Álvaro, what does the feature freeze look like for you as a Postgres hacker? Now that you can't work on any big features at this point, what do you actually do on a day-to-day basis? Is it vacation time now?
So mostly I keep track of the open items list, which is a page in the wiki site, and just fix any bugs that are reported, which are going to be recorded there.
What does that look like for the last couple weeks for you? Because so I have been working on a bug fix that someone else was working on, but had to work on something more important. And so they kind of handed it off to me, and it wasn't, and I was happy to work on it and excited, but it was totally unplanned, right? And so I'm always interested because I feel like for some reason this time of year, weird, totally unplanned stuff comes up and just sucks 2 weeks of your life up. And I guess it's because you don't say no because now you have the time, right? But yeah, I don't know. So I wonder how other hackers actually spend day to day during this time of year.
Personally, I try and keep a lookout for things that are in an area that I could help with. Which is going to be different for each person, right? Yeah.
So in the lead up to version 19, you've all been working on some big features and interesting, bunch of small stuff as well. Can you share some stories on kind of successful collaborations or first of all, interesting features that you are excited about in 19? Thomas, for example, what you've been working on different stuff or other, or what have you been working on, and what can you tell us?
Yeah, so the main thing that I committed for Postgres 19 was follow-up for the AIO stuff in worker mode, where you're using processes that run in the background and do IO work for you. In version 18, we shipped it with a pretty crude control where you could say how many background workers you wanted to run. And, the goal was to make it automatically self-tuning, but that turned out to be quite hard to do in a reasonable way. And I actually spent really quite a long time trying out a lot of different ideas and reading difficult books about queuing theory to come up with the right way to do that. And yeah, I'm hoping that it's going to be a lot easier to tune that when this is for people who are not using IO U-ring, so it's the default setting in Postgres is to use background workers for IO. And, hopefully people will now see a lot more use of asynchronous IO when they're using the default setting, because the pool of worker processes will scale itself automatically, hopefully perfectly. But I'm sure we'll finish up tuning that logic a bit over time as we learn more about it with, real world experience. But yeah.
That thread had a lot of cool like engagement from other contributors, engaging with your very theoretical academic ideas, and I thought that was cool. Like sometimes it'll be this big block of text and all this thought, and then no one ever even, there's zero replies, or people reply but just about the code. They don't actually engage with the algorithm or the heuristics or whatever. And that kind of happened on that thread.
It was fun, and it's not finished. The thing with that's all these heuristic problems where you don't really know what the right answer is, and when you look into it, you find out there's a whole field of study, right? And there's actually like 80 years of academic work and in that kind of stuff, and trying to find out without a formal training in that stuff, it can be quite hard, like actually quite intimidating to get into it. And I actually started with just kind of having a hunch about how it should work and trying some ideas out, and it seemed to work pretty well after a lot of tuning. But then people ask you really hard questions like, why? Like Andres Foreign reviewed my patch, and he looked at it and said, it seems to work really well, but I have no idea why. And I was like, I got stuck in a rabbit hole for about a week, and I still haven't actually properly replied to that. I know why it works well, but the kind of formalism for that is quite tricky to work through. But it was Dmitry Dolgov who sent me some really good pointers to books to read about that. And I mean, heuristics problems are some of the most difficult problems I find in general, because there's no real right answer. And it's hard to say when it's the best that it could be. It's a good way to spend a lot of time.
But one thing that happens all the time in the Postgres development cycles is that we introduce something in one release, and maybe it's not so great, and there are some wrinkles and problems here and there. And then next release, we improve it a little bit, and the next release, we improve it again. So in a period of that's not too many years, let's say 4 years, 5 years, we've changed completely how Postgres works in a groundbreaking way.
So I guess my main fear with that kind of thing, it's not so much that it isn't as good as it could be, it's that there isn't a failure mode where it goes nuts. Like there isn't some pattern of IO that will cause it to suddenly start some ridiculous number of worker processes, or some particular statistical property that causes it to run far too few. Both
but
of those.
Trying to avoid that stuff often is why we don't get any cool heuristics in.
I have to agree. Like these heuristics are really hard problems. I remember like we still have the BG writer heuristics that no one really understands how they work, and I've heard multiple people say that we should just rip out the whole thing because it doesn't do anything useful or stuff like that. So Melanie, can you still share stories about what went into 19 and how the collaboration worked for you?
Yeah, so I mean, I won't talk about the feature that I worked on that actually went in. I think I'd rather talk about my feature that didn't go in, which we're going to talk about later. So I work, because Thomas and I both worked on this. We both worked on write combining. So in Postgres 18, maybe 17, the read stream stuff went in. So starting in 17, we started doing some trying to do IOs in larger than one block at a time size, and for reads, but we haven't done anything like that for writes yet. And so it sounds really simple, right? It's like, well, when you make this system call to do a write, just give it more blocks, then don't give it one. But so obviously it's a little more complicated than that. But I got so Thomas could probably talk about where he ended up going down the rabbit hole. I made it really far and at the very end fell into the hole. I was like, this is good, this is ready. I feel like it's there's a stage at the end where it's not like it's committable, but it's in its final form kind of, and you're just, then you got to make it committable, and that's going to take a few more iterations or whatever. And I was like, that's where it is, and that's not where it was at all, right? And
how far were you in the development cycle when you got into that point?
This was this was February, so it's pretty far into the development cycle. It was too late to do any big rejiggering. And I think honestly, the thing that takes the most time is when you think about, okay, I need to rethink or add a new heuristic or whatever. then you need to develop, benchmark is a strong word, but like performance exercising of the worst case, the best case, and then think through all those different combinations that could be there that new heuristic would expose, and setting those all up, coming up with them and getting them to like to prove that they're exercising what you think they are takes a long time. So like when you think about, okay, I need to decide whatever, like in this case, it was that when you decide what blocks you're actually going to combine with it. So we do writes in different places in the database, right? Like the background writer does, the checkpointer does, and individual backends, if they can't have a free buffer to read something in, they have to write out something else, right? And so like any of those times, and then there's also some other cases, right? But you have to decide what blocks. What are the blocks? If you're going to write more than one block, what are the other blocks? And you can use all kinds of heuristics for that, like that, but they have to be adjacent. So I think like the most basic one is, just get the adjacent blocks and write them out, whatever. But so anyway, I think just that whole process of like, oh, actually one open question meant a bunch more time than I had just because of having to then exercise these different scenarios.
Yeah. I had an experience with I started to work on resizable shared buffers very late in the release cycle. This was only like a month before the feature freeze. I picked up or working on that thread. It was originally, the patch was originally from Dimitri Dolgov, and Ashutosh Bapat did all of the hard work. And I didn't even look at the main part of the patch. I only looked at the interface of how do you allocate shared buffers or shared memory, not even the buffers part. And it's always really stressful as you get to the end of the feature freeze or the feature freeze approaches, and you have to make the call of, is this committable or not? Can I live with this for the next release?
What did you actually end up in the end, like getting in from that?
So the thing that got committed was just some internal APIs for how do you allocate shared memory. That's always been a little bit awkward. Like it hasn't changed for the past 20 years, but now there's a slightly different interface, which makes more sense than the old one. But the thing that kind of triggered that change was to support the resizable shared buffers in the future. Like that's not in yet, but that will. Now we have the groundwork for working for that or for the next release. Álvaro, you've worked on the repacking for version 19, right? Can you share the?
I think that's a great collaboration story. I was very happy to be able to get Antonin Huska from Cybertech to work on integrating his PG squeeze tool into Postgres.
That tool has gone through many names. So can you reveal with the original code PG reorg and then repack and squeeze, or what was
so it's two different tools. PG reorg was the original one, and then at some point it died, and somebody picked up and renamed it as PG repack. And then it continued as PG repack, and then, as far as I know, it is still developed today. But it uses an odd, antiquated functionality to get things to work. It uses triggers and whatnot. So Antonin Huska was asked by Cybertech to re-implement this using to integrate scheduling into the program. And so he found that instead of integrating scheduling, he could rewrite the entire thing to use logical decoding. And that was much better. So essentially what we did for Postgres 19 was take the PG squeeze code, remove the things that we didn't really need, and put into a committable form for Postgres. And the other person involved in that work was Mikhail. Sorry, I cannot pronounce his last name. And he's been tremendously helpful to provide a lot of testing for it, to the extent that I should say, discovered and fixed a number of bugs that we had in logical decoding for a long time before, for all sorts of use cases of logical decoding. And so we have repack now.
I have a question about it. So it's an interesting collaboration story because you have something that was not in core, and then you decided you wanted to bring the functionality into core. And so someone who is sort of a maintainer of the out of core thing, working with a committer on it, it's pretty effective because you know there'll be a path forward, right? Yeah. But we try not to put things in core if they don't need to be, because then they're bottlenecked on us, right? So what made you sort of decide that, yeah, this does belong in core?
So there are things that Repack can do being in core that the outside, the third-party tool can do. Optimizations to logical decoding. How do we treat the X-mean, which limits how vacuum reacts to this other thing working? How does it preserve disk space? Yeah, other things like that. So users have been asking for an online vacuum full for a very long time. So this is clearly something that we've needed. I mean, PG Squeeze is out there, but it's not as good as our Repack in core can be.
Mikhail was also working on creating this concurrently, if I remember correctly, because I was reading those patches and following that discussion. How did that go? That did not go in, right? Do you think we'll see that in the next version?
Yeah, so that's precisely the patch that I intend to work on for PG20. So it's quite novel. It uses a technique that I don't know. He came up with it. Clearly, he has quite some imagination to think of these things, and I think it is going to be a very good use of our index AM functionality in a way that it's not about creating. It is creating an index, but it is not it's indirectly creating an index in order to support the creation of another index. So it's quite cool.
Yeah. So we talked about the next version already. Well, Melanie and Thomas, what do you plan to work on for the next version after 19?
Go ahead, Thomas. You go first.
I really wanted to get a couple of multi-threading patches into 19, and
me too.
Unable to do that. And partly that's because, and I'll talk about what they are in a moment, but partly that's because as apparently the entire software industry is experiencing, there's a lot of security activity happening. There's just a lot of bug reports that have to be addressed, and in the end, one of our most basic duties is to protect people's data, right? So I personally, as did Heikki, got involved in addressing CVEs that were pretty scary and had to be dealt with, and I just kind of dropped everything and did that for a while, and it meant that there's a couple of things that I had really wanted to get it to 19 weren't done. And so the first one is Heikki and I have been bouncing patches back and forth for probably about 3 years now to replace the way that Postgres backends communicate with each other, the way they wake each other up, which sounds like a very simple thing, but there's just a lot of code, and you've got to come up with a really good abstraction that covers everything, and that has a long-term future that works well with multi-threading. But will also work well with multi-process mode, because we've sort of been, a group of us have been sort of working together over the past few years to build consensus on what it will mean to be multi-threaded, and what does the series of evolutionary steps look like, because we have to consider the whole world of the whole ecosystem of extensions and so on. So we have this plan kind of worked out where we're going to support multi-process mode and multi-threaded mode at the same time for some time.
Hopefully a very short time.
Maybe a short time. We get to argue about that in the future. First problem is actually making it work. And so one of the things that I think we got into a reasonably good shape, although there was still plenty of details to argue about, is this refactoring of the system for wake-ups between backends. And there's another thing which has 3 or 4 other patches that I have that are in that space as well. They're targeting things that multi-threading needs. One of them deals with subprocesses. So even when Postgres is multi-threaded, in the glorious multi-thread future, whenever that turns out to be, you still have to run background processes sometimes. And the way that we when you run copy and you start a background process or something like that. So dealing with backend shutdown and managing processes that are owned by a thread and things like that. There's a whole series of things that involve redeveloping a sort of a sub-process management module. And actually, the more I looked into that, the more I found that, there are actually bugs. There are ways that bad things can happen right now because we don't actually model that stuff very well,
Thomas, why do we need sub-processes with threads still?
Yeah.
Oh, because you run copy with a sub-process. You can say copy from program. The archiver can run. These are just a few little edge cases, right? Like in general, Postgres itself won't have any processes, is the plan, right? But sometimes you explicitly tell it to run a sub-process because you want to run an archiver script or something like that. So it's all, when you tell it to run a script for some reason, basically. And, just the management of that kind of stuff. So that's one area that I did quite a bit of work on, and unfortunately didn't get time to even post for 19. But so that's something I want to
have you guys been working on the lachification thing recently, or was that all a long time ago? No.
Yeah, we haven't really been actively collaborating in the last few months.
Not for the after the feature freeze, it gets really like you have other priorities, but I plan to start working on that as soon as we open the development for 20.
And I plan to review it. I thought it looked pretty good. I thought there were some things to discuss,
and that is the kind of patch we want to get in early in the release cycle, and not even if it was in pretty good shape already for this release, it's not something you want to land at the last minute.
Yeah.
So hopefully in 20 we'll have some more pieces of multi-threading. I'm not in the game of telling anyone when I think you're actually going to be able to use multi-thread Postgres, but I think as a community we've finally got over the hump of actually agreeing that we're going to do this, right? I mean, for many years actually, there were a lot of people who were saying that it's a good thing that we're not multi-threaded, but none of the arguments really made sense when you looked into it. So I'm very happy that part of the problem has been solved, but there's still so many little sub problems to solve. And another major area is deciding, it's superficial stuff really, but deciding how we deal with Unix and Windows portability for that stuff. There's a couple of different ways you could do it these days because now C has threads. Should we use those? There's a few things like that, and I've got a bunch of sitting on for.
It seems like there's lots of discrete sub-projects in the multi-threading project that all seem like totally different, and like different people could take them on. But for some reason, it seems like we haven't really got that many people working on it or doing it. Like it just seems like really under staffed.
I mean, that's Postgres development for you. Like,
but Postgres,
that's how this stuff tends.
Well, not all projects like lend themselves to breaking down into those individual pieces as well. Like take AIO, we have, at any given time, maybe like 7 people have contributed code to it, but 90% of it, I think 80% of it, I guess Thomas did worker mode, which was a ton of work, but like 80% of it is Andres, right? And then there are sub projects, but it's not quite as, they don't sound quite as distinct and totally unrelated as the sub projects for the multi-threading. I was just trying to start stuff, but I love collaborating on projects with other people. As I've worked in Postgres over the last, it's been 10 years now, I think. Yeah. Anyway, like less and less on, because you're working with people asynchronously. So originally I liked pair programming, and then I sort of that's like you're working simultaneously on the same thing, right? And then it sort of downgraded to like, well, we'll work on the same patch, but just like, maybe it's at different times, or both contributing code to the same thing. And then it like became further and further apart, and eventually it was like, maybe we'll be working on the same general area of the code or feature, but on different sub projects. Weaker and weaker collaboration, I guess. And some of that is like I was a new engineer at the beginning. Some of it's seniority, but I think some of it is like the way that people in Postgres work. They tend to work alone. And I've been doing all these interviews of people for the 30th anniversary, and like starting when Postgres started, people worked alone. And they're like, I'm sure that's changed now and everyone's collaborating a ton. And I'm like, I mean, reviewing each other's patches is collaborating, right? It totally is. But it's different when you're like working towards the same goal. For both of you, getting that patch in is your top priority. And we don't do that very often. And the only time of year when the stars align usually is right before feature freeze, right? And I don't know.
But there's another form of collaboration, though, that happens with some good planning and then some, like, architectural changes. Like, think of the AIO stuff where we kind of knew that we decided to work on reads first because we knew that you had to change all these places all over Postgres to change it to a streaming model. And it was going to be hard. And you would kind of need an expert in index stuff to do the index thing, and like no one person could do that. It would be absolutely mind-boggling amount of work, right? So we tried to come up with an abstraction and then set the the ball rolling by doing some easy cases, and then then we tried to get on go to pgconf.dev and so on and say
and
hey,
get people to do the users, right?
Like,
but that's whole thing is designed to collaborate with having to interact with each other as little as possible.
Yeah, but it's a way to, because you can't, in an open source community, you can't really tell people what to do. There's no boss, right? So, but if you can open a new, field to work in by coming up with, through a collaborative process, coming up with sort of a new architectural way of doing things, and then let experts in different areas contribute when they're ready to do so. That seems, I thought that went pretty well. I mean, it is an ongoing process.
I think multi-threading works in that way also, because you two have been doing, I mean, Heikki and Thomas have been doing some things, and we also have Peter Eisentraut doing other things. And it's all moving forward towards the idea that we're going to get rid of processes someday.
Yeah, there's different kinds of collaboration. Like the multi-threading is an example of all of us have been kind of working alone. Sure, we review each other's patches, but we're not actively like iterating together, which is a different kind of collaboration. I remember with Melanie, that was already in 2017, I think. And this was really at the end of the feature, like just before the feature freeze. And I think that was kind of why we, like that forced us to work that way. But we like iterated real quick on the patches and like sent patches back and forth real quick. And like agreed on, okay, I'm going to look at this now. So you have the next version, within the next 5 hours. And like, I have not really experienced that with other projects within the Postgres community. I had a little bit of that with Ashutosh, with the shared resizable shared buffers, because that and that was again because we were very close to feature freeze. So I feel like you kind of need a deadline to do that. But traditionally, we haven't really done that in the Postgres community.
There's an energy that comes with that you feel like you're on a team with someone, which is different than when you're doing something on your own. You don't know if someone's going to look at it. You don't know when, right? So you put it out there and then you start the next thing on your list. And then by the time they look at it, maybe you're not, but you have to context switch it back in. And so you lose the momentum. There's a lot of stopping and starting, right? And I think like when someone was asking me about like how we could have more velocity, and people always ask that of us, how do you get more stuff into Postgres? And I was like, I mean, one of the reasons that you sort of do have those momentum stops and starts that happen is we're all working on different things.
One thing that I'm actually curious to hear your experiences on time zones, because I find that being on a different time zone kind of adds to the problems, you can maybe also take advantage of that. I remember a long time ago, I found that in my mornings, I'm in Europe, in my mornings, if I pick up bugs that people have reported, I have like 4 to 5 hours to fix them before the people in the US wake up and get them fixed. Mostly Tom gets them fixed real quick. So in the
Yeah.
morning, I would look at the bug reports and try to do, get this stuff that I can do in a few hours and get them fixed. But yeah, I'm curious to hear your experiences, especially Álvaro and Thomas, because you have lived in very different time zones.
Yeah, definitely the time zones sometimes complicate things when working with people in the US or in the Americas or even Japan. So I think Japan or New Zealand.
Yeah, we have all the Japanese contributors.
Yeah. That makes everything slower because everything you have to wait for anything.
Yep.
Yeah. My experience is that people who work on open source software don't really tend to have the right time zone for their country anyway. So you could be surprised when you get the reply.
That's very true.
Another thing is kind of what you were saying, Heikki. Sometimes you send a bug report just before you log off or whatever, and then you wake up in the morning and it's fixed. That's pretty cool.
That is really cool. That's true. That's the thing with time zones where it's like, or you post a patch and someone posts a review and you wake up to it and that's like a present under the tree.
Yeah,
that you
it is
weren't
pretty cool.
expecting. No, there's that feeling of, I have noticed like, I don't know, you can kind of figure out areas that you work on that people are more or less interested in. And even though it's not intentional, I think maybe it's intentional, but it just feels so good to have people look at your code and respond to your ideas and reply to it that I definitely feel like I calibrate towards trying to work on things that I think someone else might actually engage with so that I can have that collaboration.
Yeah, it's very rewarding for sure. All right. Thanks for the discussion and looking forward for version 19 and future developments.
That was an amazing panel.
Yeah.
So I have a question. Like, where will we go? From threads? From process per connection to threading.
Well, I'm repeating myself when I say, we're not ready to make any, hard sort of fixed commitments about that, but it is happening, and it's a long series of steps, and it's a fun project. It's what I'm working on at the moment, and
I love it because I still remember it from the paper, The Design of Postgres, by Stonebaker and Laura Sayroy, stating that it's a temporary solution, as back then even threading wasn't standardized.
It wasn't standardized, exactly, and it worked in weird and wonderful ways on the different Unix systems they had.
Yes, the paper even states it would require a specialized operating system to implement it a different way.
Right, and I think probably if they'd I guess with hindsight, you could say that if they'd sort of stayed on that path, or we had stayed on that path in the early days, with that in mind, they could have made things a bit easier by not doing everything with so many global variables. But we'll eventually shake them all out and make that work. But it's actually been going on for quite a few years now that we've been gradually chipping away at small things. Not using the default locale and things like that. Just finding all these little places that are a kind of global state. So.
Yeah, absolutely. And by the way, there's a vivid discussion going on in the Discord. So if you haven't seen that, let's make sure that you know how to join. Okay. I'm getting ahead of myself. First, the socks proxy. You go to the survey sock, and you're up to get some socks. So after every talk, by the way, go and leave the feedback for the speakers, for the panelists in this case. It's great, especially for first-time speakers or even for battle-tested veterans that are going to every conference. Getting talk feedback is very, very important. I mentioned the virtual track. Thomas?
Oh, yeah. So jump into the Discord, as you mentioned earlier. People are going to be discussing the talk as it happens, and in many cases, you might find the speaker is available to answer questions, and if not, there's plenty of knowledgeable people to chat with, and yeah, see you there.
Yeah. So yeah, go to Discord, ask questions, get swag.
We will send it to you anywhere in the world. There we are.
Okay. Next talk is by a former colleague of mine, Marco Slot. Marco is currently, I believe, at a principal software engineer at Snowflake, and previously he worked for Citus Data back before Citus Data was even acquired by Microsoft. And then I had the opportunity to work for many years with Marco within Microsoft on Citus and related projects. And Marco will tell us today about PG Lake, which is the embedding DuckDB inside PostgreSQL to give it that big data capabilities. I'm looking forward to the talk. Maybe let's have it rolling.
Hello, everyone. I'm Marco Slot, and my talk is going to be about PG Lake, which is an open source extension for connecting Postgres to the wonderful world of data lakes and lakehouses. So I'm going to talk about how you can use PG Lake to import, query, export data in object stores and use it for fast analytics using table formats like Iceberg and file formats like Parquet. All right, so let's get started with PG Lake, Postgres as a lakehouse. But what does that mean, lakehouse? I have to admit that when I started this project, I didn't really know the term lakehouse. I had heard it, but I didn't really know what it was. And it sounds also a little bit like a marketing term, and it sort of is, but it actually also points to an important architectural trend that has been happening in the data space, in the analytics space. So I think over the past few decades, like most companies organize their data in two ways, usually not one or the other, usually both. One is a data lake where you have something like object storage and you collect files, lots of files, log files, CSV files, Parquet files. And it's a very easy place to write to. Any application can just, add more files. Usually there's no limit to the storage. The storage is pretty cheap. But then processing that data can be pretty complicated and slow because maybe the files all have a slightly different format and need to be converted. And they're not in an analytics optimized format. But it's a very accessible, kind of interoperable storage layer for data. A data warehouse kind of structures the data into tables where you have columns and types, and you can do joins. And they're usually very efficient. And so that's a very nice model, but you have to put some effort into structuring the data, and it usually has a particular client and SQL syntax that you have to use. So it's less accessible than a data lake. So a data lakehouse is basically the combination of these two architectures, that you store the data in an object store like Azure Blob Storage or Amazon S3. But it's structured like it is in a data warehouse as a table with columns and types, and you can do SQL on it. And so there are certain table formats that have been defined that can be stored as files in object store and then also modified, and you can do schema changes. And I think the most notable and most popular one is called Iceberg. So we'll talk about Iceberg more because it's a core part of PG Lake. But Iceberg is basically an open table format. So it defines a protocol, a format for grouping a set of files into a table and defining what the current schema of the table is, what are the past versions of the table, some statistics on the files. And this is in like open spec. It's very community driven. And so lots of different engines have implemented support for querying Iceberg or for writing Iceberg tables. And that allows you to use different engines on the same data. You store data once, you can use different engines. And on those tables, you can also do transactions, which is very powerful. And you can change the schema. There's facilities for things like partitioning and other important features that you usually find in a data warehouse, but implemented in top of effectively a data lake. So PG Lake essentially brings this technology into Postgres. So number one, it adds Iceberg as a really native feeling table format where you can create Iceberg tables from Postgres and query them and do updates or import existing Iceberg tables. But it also actually connects you to the sort of kind of more raw data lake where you can import and export and query Parquet files, CSV files, JSON files, and even some other file formats. And work with those very easily via SQL. And then when you're using Iceberg or Parquet, it can also run very fast queries on analytical queries on those tables by delegating part of the query into another query engine called DuckDB. And then finally, I think one of the most powerful things about PG Lake is really that you can do these things in a way that's just using plain SQL and with transactions. And that allows you to build these kind of relatively simple data pipelines where you continuously take data from your data lake, ingest it into Postgres, or archive it into Iceberg. And I'll show you a few examples of that later in the talk. So PG Lake, we announced it in November as an Apache licensed open source project, but it has a bit of a longer history. So we started in early 2024. And in that year, we developed it at Crunchy Data, and we added it to sort of Crunchy Data products. So in November, we added the initial Iceberg in Postgres product. But then in June last year, we were acquired by Snowflake. And so within Snowflake, PG Lake sort of took on a new meaning where, A, it became an open source project, and B, it became a very core part to the Snowflake Postgres service. But it also became more focused on the interoperability aspect between Postgres and your data lake and Snowflake and other engines. So some more concrete examples, like, this was all dry talk. Let's look at SQL. So one of the things you can do with PG Lake is you can create a table directly from a file. And it's very easy because you don't actually have to specify, what the file looked like, what columns it has, what types they have. It'll try to infer that by just sampling the CSV file, looking at the header, and constructing the table that way. So that makes it very easy to just query a raw file. You can also load more data into that table just using copy commands. You can give URLs pointing to CSV, pointing to Parquet. Now, maybe you don't want to load the data into Postgres because it's a lot. You can also create a foreign table that points to a file or a set of files using a wildcard. That's actually a very nice pattern because if new files show up in that prefix with star.parquet, then if new Parquet files show up, then they'll automatically show up in this table. And one of the nice things also about having the data in Parquet is that when we query that table, we'll delegate part of that query into DuckDB, which is much faster than Postgres. And finally, you can also export data from Postgres. Just run a query and export the result back into object storage. And that's really nice because then you can build these pipelines where Postgres imports some data that's maybe written by one application, does some processing, exports it to another application. Maybe your web application or mobile app can directly fetch it at that point. So it really becomes more of this hub in your overall data architecture. So, but dealing with files is always a little bit nasty because it's very easy at first, but then you have a lot of files and they're all a little bit different. There's no, you change your naming scheme a few times. Now there's more columns in the newer files, or something got renamed, or is a different type. So that's where organizing things into a table becomes very useful. And so Iceberg is a way to essentially take a collection of Parquet files and give it a structure through a layer of metadata files that describe statistics, which set of Parquet files are currently part of the table. It can specify things like this Parquet file describes what's deleted from this other Parquet file. it can also give statistics of store statistics of the Parquet file, such that an engine that reads those metadata files doesn't necessarily need to go and read the data files for a particular query. And so an engine that implements writes into Iceberg, like PG Lake, it will translate those writes into the generation of data files, Parquet files typically, and these metadata files that reference the data files. And so there's one top level metadata file that's like the current version of the table with the schema and like with the current snapshot, and it points to the sort of the latest version of the files. And so once you have that metadata file, you can discover exactly what's in the table. But to actually do transactions on these tables, like the object stores in which these files are stored are not suitable for that. They don't really support transaction mechanics like Postgres does. So the way that's solved in Iceberg is essentially by using a database, where it's usually called a catalog. So a catalog is basically a database with an API, and the catalog stores the latest version of the metadata file. And so when we do a write or do a transaction on an Iceberg table, we write a bunch of new files, and then we tell the catalog, hey, here's the new version. And if that last step fails, then essentially the transaction rolls back. And so that's what gives us real kind of transactional guarantees. Now, there's a lot more to an Iceberg implementation. So one of the things that tends to happen is you insert, and now you have lots of small files. And so what PG Lake does, like every 10 minutes, a background worker wakes up and it goes and sort of smashes those files together. That's called compaction. So maybe you had, a few 1 megabyte files. Now they become one big, 20 megabyte files. We can also do things like partitioning in Iceberg, but you can also actually use all the Postgres features in PG Lake. Like you can use sequences with Iceberg tables and triggers and constraints. So it's really a deep integration. And essentially, we say they walk and talk just like Postgres tables. So you can create a table using Iceberg instead of using heap. So what that looks like in Postgres is essentially you just create a table using Iceberg. And other than that, these tables behave just like Postgres tables. You can insert, you can update, you can add columns, drop columns. You can have sequences and other features that you might want to use with Postgres, like stored procedures. You can do queries and stored procedures. But the big benefit is that they now sit in cheap compressed storage and essentially infinite storage. You can also do very fast analytics on these tables because the queries are delegated. And they're very accessible to other applications. Like other applications can just directly get the data from object storage. They don't have to talk to Postgres. Now, of course, there are some trade-offs. You don't get everything for free. So a limitation of Iceberg tables in PG Lake is you don't have indexes, you don't have foreign keys, you don't have row-level security. Those are kind of general limitations of Iceberg. So maybe there are actually proposals to add indexes as well. So maybe we'll have it in the future. Now, the way this is achieved, like that we have just this whole new table format, is through extension APIs. And so Postgres gives you the ability to, as an extension, to intercept pretty much any command that comes into the server, any SQL command, any DDL command, any DML command, and do something different or additional to what Postgres would normally do. And so we can intercept alter table commands on Iceberg tables or queries on Iceberg tables. And then, for example, when we get a query that only includes Iceberg tables, very often we can delegate that query into DuckDB, which makes it very fast. But we really use a combination of many different types of hooks in Postgres to kind of create this very seamless experience. Now, under the covers, one of the things we did was, so we integrated DuckDB, which is this multi-threaded vectorized query engine. It's very fast for analytics. Last year, I gave a talk kind of explaining why it's so much faster at analytics than Postgres. But it is it's also like has a big thread pool. It uses a lot of memory. So one thing we couldn't do is put a DuckDB instance in every Postgres process, because whenever you connect to Postgres, you get a new process. And if we have DuckDB in each process, it becomes, we'd run out of memory very quickly. So instead, we have this extra server that we run alongside Postgres, and all the Postgres sessions connect to that server. So when a query comes in on Iceberg tables, the query optimizer in PG Lake will check what part of this query can I delegate into this PGDuck server, and it'll send it there. And we actually implemented the Postgres protocol, so we're just talking Postgres to Postgres essentially. And then DuckDB will get that query and execute it, and it has the credentials to talk to S3, so it can fetch data files, and it often will fetch like parts of data files to not have to download all the data. But it also has a cache where we sort of store all the files, so often it doesn't have to talk to the object storage at all. Now, having the data in Iceberg is very useful, and because now you can do fast analytical queries, other systems can query it, but how do you actually in practice get it into Iceberg? Like when we first built this, we thought, oh, this is great, people will use this, and then we realized something is missing. Like there needs to be some piece that helps you get your Postgres data into Iceberg, or your Iceberg data into Postgres, or your data lake data into Postgres. And so this piece became PG incremental. And the way, the basic idea with PG incremental is that you want to select, like you have some incoming data, and you want to move that into a different table, let's say. And the first time you do that, you want to take all the existing data and move that. And then after that, you periodically want to take all the new data and move that into the destination table. And so we look for a pattern where we can do that for different types of source data. So maybe the source is a Postgres table, which has a sequence number. And so PG incremental helps you run a query where you take all the sequence numbers that haven't been processed yet, or you can run a query where you divide the data into time periods based on some column, and you take the time periods you haven't processed yet, or you look at the object storage, see which files are there, and the first time you take all the files from there, and as new files show up, you just take those files. And the guarantee it gives you is that it processes each input value once. So each file will be processed once, or each row will be processed once. And so an example of that, for example, maybe you want, you have events coming into Postgres. It's a very common pattern that you have devices, maybe they insert records into Postgres continuously. So there's an append-only table. It has very low response time from the application perspective. Usually you do something like partitioning to drop old partitions very quickly and to have like faster queries. And maybe you keep like the last 7 days of data in Postgres with some indexes, so you can quickly look up the last 10 events or something like that. And then after 7 days, you drop the data. But maybe you actually also want to keep like all the data you've ever collected, just in a more compressed form, and in a way where you can do fast analytics on kind of your historical data. And so Iceberg is great for that. So what we can now do just from Postgres is we can create the Postgres table, then create an Iceberg table that has the same columns. And then we can set up this PG incremental job where we take all the events based on a sequence number. So the first time this runs, it just takes all of the sequence numbers that are already in the table. And then it will run again every minute. And each time with a different parameter. So with $1 and $2 keep changing every time we run this query. And it'll progress. So maybe first we process 0 to 100, then we take 101 to 110, and 111 to 120. And so we keep progressing. And it also, under the covers, does a little bit of magic to make sure we don't process a range before that range has finished. So if there's still ongoing transactions that are using older sequence numbers, we wait for that. And so this is a very simple pattern. In 3 steps, we have automatic archival into Iceberg with fast analytics, and other applications can query this data. A similar pattern, but still quite different in some ways, is I have a table that I use as a queue in Postgres. So I just need a quick and durable way to write an event somewhere, and I don't need it to be in Postgres. I just need it to be in a place where other systems can query it. So again, we create a table, in a Postgres table, which we use as a queue. Then we create an Iceberg table, which we use as kind of the destination. And in this case, we don't really need PG incremental. We can actually just do a regular PG cron job. So it's like a periodic job that runs every 10 seconds, which deletes everything from the queue and inserts it into the Iceberg table in a batch. And so this batching is quite important when using Iceberg. You typically don't want to do single row inserts into the Iceberg table directly, because you'll get horrible response times of a few hundred milliseconds, and maybe only one at a time. So that's much worse than Postgres. But if you do it in batches, that's fine. Like a large batch probably also still takes a few hundred milliseconds, because the time really goes into writing those files into object storage. And that usually has some kind of initial overhead. And then another pattern that we see quite often is actually going in the opposite direction, where you have data not being written directly into Postgres, but written into object storage, and you want to get it into Postgres. So these could be logs from a different application. Maybe it's writing compressed JSON files, and you want to get that into maybe a Postgres table. Could also be another Iceberg table. It's very easy to make that choice at this point just by saying using Iceberg or using heap. And then so with PG incremental, you can also create a file list pipeline where you say everything that follows this URL pattern, take all of those files and run my command. And it actually does it in smaller batches, so it kind of does 100 files at a time. But so it will insert into the table and select from this foreign table where the file name is in this set of 100. And then once it's processed all of the files that are already there, it just periodically checks, are there new files? If yes, we'll run the insert select command again. And that way, very simply, with 3 commands, you've built this whole ETL pipeline where you ingest data from object storage into a Postgres or Iceberg table. And if it's a Postgres table, you can add indexes and that kind of stuff. And so you'd normally need really quite a lot of tools to build this without something like PG Lake. But the other area where we find this to be an extremely useful pattern, apart from just doing things purely in Postgres, is actually to connect Postgres to something like a data warehouse. Of course, when I say data warehouse, I think of Snowflake, but it can be also another data warehouse. But so one thing we often see now is that PG Lake is becoming this bridge between your operational database, Postgres, and your analytical database, your data warehouse, like Snowflake or other systems. And Iceberg makes that very easy, because you just write into an Iceberg table on one side, and then you can query it directly on the other side, because it's this standard protocol. And so one thing we did in our Snowflake Postgres service is kind of try to make this PG Lake integration really seamless. So if you create a Postgres instance and you connect to it, PG Lake's already there. And there's also some object storage kind of attached to the Postgres instance. And so if you create an Iceberg table, that's where it'll go by default. You could also place it somewhere else, but by default, it goes into the managed object storage. And so you can extract data from your Postgres table just by running a create table as or insert select. And then immediately in if you're a Snowflake user, you can create an Iceberg table, or you're not really creating it, you're referencing it. And then you can query that data directly. And then you can do all the things that you can do in your data warehouse. You can build further pipelines there, or you can do some AI jobs, or use all the functionality of both systems combined. So that's pretty nice. So in summary, basically PG Lake is about integrating with your data lake, with formats like Iceberg, with file formats like JSON, and by extension integrate with other platforms. It lets you interact with data in object storage pretty much through like the SQL you're familiar with, without lots of external tools that you need to run. Everything is sort of self-contained. Especially with Iceberg, you have these transactional guarantees, and that's also what things like PG Incremental rely on, that we can do a transaction on an Iceberg, or a transaction that writes to an Iceberg table, but also from a Postgres table. So that's I can do the bookkeeping on what I processed in the same transaction as the actual processing, and that's very nice. And so and then combine that with periodic job schedulers like PG cron and PG Incremental, you can do this incremental processing just within your database. And it also really simplifies your life compared to having a lot of external tools. So yeah, I hope this gave you some insight on what PG Lake is, what you can use it for. I'm on the Discord for any questions. You can also email me. For now, thank you very much, and see you at the following Posette, maybe. Let's see you next year.
Thank you, Marco.
Thank you so much. Yeah, as Marco said, he's in the Discord if you want to chat about anything.
Yeah, and he's already answering some questions about the talk.
I love the way it has such simple commands and infers so much about data structure, so that it's some cool examples.
Yeah, like I'm starting to think like what really defines Postgres, right? Like where does it start, where does it end? It's a very tricky question to answer.
Yeah, I like that idea of catalog role. That it's one of the main ideas I got from that.
Okay.
Cool.
Talking about talking, we actually have a great podcast to talk about that had over 40 episodes by now. Many of our speakers were guests during the podcast. I'm talking about talking Postgres with Claire Giordano. You can find it using the QR code. If you are on Discord, you can also listen to it live when the episodes are aired.
Cool. This podcast actually started life as I think the original name of it was something like Pathway to the Conference.
Yeah,
it had a different name at the time.
Path to CytusCon, I believe, because it was back then called CytusCon, and we renamed the conference because it's not only about Citus, it's like more broadly a PostgreSQL conference.
It's a pretty cool podcast to tune into if you want to hear from people who've. It's got a lot of. I sort of think of it as being the sort of oral history sort of project of Postgres, because so many people who've been involved in it along the way have great stories to tell, and yeah,
absolutely,
I enjoy listening to it. All right, so next we're going to hear from Adithya Kumaranchath, and he works at Microsoft Azure on migrating databases, and he's going to be talking to us today about migrating very large databases, so all the kind of problems of scale that brings into your life. So, take it away.
Hi, my name is Adithya Kumaranchath. I'm a principal engineering architect in the Azure Data product group. So my talk is going to be about migrating very large Oracle databases to Azure database for PostgreSQL. So if you're a decision maker, or if you're looking to migrate to Azure Postgres, then this talk might be interesting for you. So let's get started on migrating very large databases from Oracle to Azure database for PostgreSQL. So a quick rundown of the session for the next 20 minutes. So I completely understand that 20 minutes is going to be a really short time to deep dive into all of these topics. And what I intend to do from this session is give you pointers and checklist, a quick checklist which you can keep in mind when you are migrating your Oracle workloads to Azure Database for PostgreSQL. So over the past years, customers have always come and asked me this question: what is that? What are the things that I need to think of when I'm migrating large databases to Azure? Because migrating large databases to Azure is not easy. One is the size of the data. Of course, there is there's that bit which is usually challenging, moving all of that data across. But also, what is to be bear in mind is the complexity of the database code itself. So when you're moving to a managed service like Azure Postgres, you also need to understand how to size it properly and how exactly to ensure that you get the right level of performance. So I'm sure many of my colleagues as well have talked about these topics. So why do customers move to Azure Postgres and Azure, of course? So first of all, it is to adopt open source because there is no license cost. It's a community-driven software. PostgreSQL, as you know, is one of the most leading community-dependent open source software out there, and it's one of the leading technologies. Customers can reduce costs. For example, if customers are running Oracle workloads, then obviously it's going to be cheaper for them because they're going to avoid license costs in Postgres. They avoid vendor lock-in as well, because if you're running PostgreSQL, then of course you can move to other clouds as well, not just in Azure. So, and then there is manageability side of things. So when you're moving to a platform as service, the backups are going to be managed by Azure. The updates and patching are going to be managed by Azure. So all of these tasks that you used to do in an on-premises environment, which you used to do manually, are all going to disappear. So that becomes much easier to manage. Then comes the interoperability. So there are a lot of extensions which PostgreSQL offers, which you could use in your development. You can, for example, right now, AI is a big buzzword in the industry right now, and there are a lot of extensions which will enable AI use cases and lets you adopt those technologies. Then the other thing is community and ecosystem. PostgreSQL, as you know, is heavily community driven and helps you adopt those changes at a faster pace, and helps you get assistance as needed from the community. So these are some of the reasons why customers choose to move to Postgres from Oracle. But the move to Oracle doesn't come easy. There's always a lot of challenges when you're moving from one database technology to another. These are a few challenges that you would have to keep in mind when you're moving from Oracle to Postgres. One of the key challenges is schema compatibility. So, for example, the changes in constructs in Oracle versus the change of constructs in PostgreSQL. So you have different data types in both of these database engines. It is, we need to bear in mind that these are two database technologies and they have starking differences. So and if you are running a very large database in Oracle, then over the years, you have accumulated a lot of database code, which means you have a lot of packages, you have a lot of procedures, and moving all of those database code to PostgreSQL is going to be a complex task. Fortunately, we have tools to do that. We have tools like Oracle PG to do that, but this is something that you have to keep in mind when you're moving a large database, because the amount of code that you have in your database can lead to complexity. It can lead to increase in the migration timelines. Of course, when we talk about large databases, the data itself is a challenge. Imagine you have multi-terabyte database and moving it from on-premises to Azure, it's going to take a lot of time, and it's going to take proportional to the size of data you have. Now, that itself is a challenge, and doing that efficiently, doing that in a way that meets your downtime SLAs is something that you need to keep in mind. So at the start of the migration, these are a couple of things that you need to basically list them down and keep in mind so that you can handle them efficiently. For example, if you require a low downtime migration, then imagine migrating 30 terabytes of data over to Azure, it's going to take you a few days, and it is going to be dependent on the network bandwidth between your on-premises infrastructure and Azure. And so in order to achieve a low downtime, you need to ensure that you plan this migration in a structured fashion. And luckily, we have tools to do that. But then it's all about planning so that you don't have any surprises and you are able to move this data efficiently. Well, cost is one of the key reasons why customers move to Azure Postgres, but at the same time, the cost becomes a moot point if performance is not met. So meeting performance is one of the main points for customer. So having a predictable performance is also something that customers expect migrating to a new database as service. Now that can be challenging because of the size of the data, because of the complexity of the code. So that is something that needs to be kept in mind as well when you're migrating to Postgres. The other thing is right sizing. So because you're moving from an on-premises infrastructure, which is usually over-provisioned, you're moving to Azure Postgres, which is a managed service. So you need to size it accordingly so that you get the right level of throughput and right level of IOPS. So that is something that needs to be taken care as well. Luckily, we have tools to do most of these tasks, and we have tools like Stream, which can replicate data from Oracle to Postgres in near real time, which can help you with migration. And many of our customers use tools like that in order to achieve that near downtime migration. So I'll talk about that in a bit when we cover customer stories. But it is fortunate that we have tools to help us with these kind of migrations. The other important thing is managing maintenance of the database itself. For example, how do we manage the table bloat? How do you manage the cleaning up of the database, monitoring of the database, and scaling of the DB? That's also an important thing to keep in mind when you're migrating large databases, because as you know, the data size the data growth can be significantly faster in a large database, which means that you need to run those maintenance tasks more periodically without being invasive to the production workload. So that's something to keep in mind as well. So I think the best way to explain this would be to explain it through a story. So basically, I'm here to talk about a large bank in Europe who migrated their Oracle workload to Postgres. In the beginning, they were a bit skeptical because they were an Oracle-friendly customers and they had tons of experience with Oracle. They ran many databases in Oracle. So moving to Postgres, they were very skeptical about it. And but then after seeing that they could reduce their costs both from a license perspective as well as from an operational perspective, they decided that they would like to try that approach. So they started off with a POC, which they ran for a few weeks, and then they did some performance tests. And as part of the POC, they uncovered a lot of challenges. So if you're looking to migrate a large database, the first step would be to do a POC. So basically, start by migrating the data. Start by first converting the schema. That would be the first step, and then migrating the data, and then run some performance tests and see if you're meeting the performance that you expect in the new database. The challenges that they had was mainly with data types and partition. So as you know, Oracle and Postgres have different partition schemes, and the handling of those partitions are automatic in Oracle, but then in Postgres, they have to be manually handled. So they had challenges there, but they were able to manage it pretty efficiently using PG Partman and other extensions that are there in Postgres. And they did have a lot of performance issues when they migrated to Postgres, but then it was just a matter of tuning the system because it's a new database engine, and it's expected that there will be some performance issues. So they had slow initial load data performance, and their batch loads, which used to take a few minutes, were spanning to hours, and they had to sit and spend a few cycles in order to tune the performance and ensure that they got the performance that they expected. So the best approach that they took was that they did a phased migration. So although their data size was somewhere around 16 terabytes, what they did was that they first migrated part of their data, which was kind of an archival data, in a retrospective fashion. And what they did is that they migrated the live data. They used tools like Stream to migrate the live data and to keep both the source and the target in sync. That actually helped them in achieving a near zero downtime cutover, because by just keeping the live data in sync, they were able to manage the transactions from their live applications and cut over successfully. Another interesting bit was parallel data loading. So they had partitions in Oracle. They aligned those partitions in Postgres and loaded the data in parallel using services like Azure Data Factory. So Azure Data Factory is an ETL tool, cloud-based ETL tool, which you can use to load data from Oracle to Postgres. And what this customer did was that they created copy pipelines and loaded these partitions individually. And because these partitions are individual tables, they could get performance, much higher performance, because these data loads were happening in parallel. So that's something that's interesting, I felt, because that way they were able to copy the data more efficiently. One of the things that worked really well with this customer was their focus on testing and tuning. So like I said, because Postgres is a different database engine, it is expected that after migration, there will be some performance issues. And it is expected that some of the queries which you fire against the DB doesn't work as expected. So in that case, the customer took some cycles and ensured that they did the tuning exercise where they identified the top queries from their Oracle environment, and then they benchmarked it against the newly migrated PostgreSQL database, and then they started tuning those queries. And that exercise, I think they spent at least a couple of months in doing that exercise, and they did at least 4 or 5 tuning cycles where they continuously tuned the queries that they found not performing up to mark. And they kept on refining them until they achieved the performance that they expected. So these are some of the key learnings from that migration that I repeatedly use with my customers, because what I understand is that there's no way to migrate a large database without complexity. It is going to be complex, but then the way to break that complexity would be to do it in phases, so that you're able to meet your timelines. So the key things that the customer achieved was because they had a phased migration approach, they reduced the migration downtime. They had a few minutes of downtime, and the downtime was only during the cutover period when they cut over from their Oracle database to the Postgres database, and the performance was actually surprisingly much better than Oracle. It's not actually a surprise, because in most of the cases, from my experience, after migrating to Postgres, it is generally observed that the performance of the queries is much better than Oracle. And the customer also found that they had a lot of cost savings after migration. So a typical migration lifecycle starts with schema validation, and you would do the POC at the beginning of the migration, a few weeks beginning of the migration. And the first step would be to convert the schema using tools like Aura to PG. Aura to PG is an open source tool which is used by many customers to migrate their schema to convert code basically from Oracle to PostgreSQL, so PL SQL to PG SQL. And that's the first step of migration. And once you have converted the code, then you can deploy the schema in PostgreSQL. And one of the key things would be to identify what the target cost would be, as in how much cost you would be incurring when you move to Azure Postgres. And you can do that only if you know what's the SKU size, what's the compute size that you're going for. And that would be the next step. So identifying what is the right SKU size in Postgres so that you can plan your production environments. And in order to do that, you need to identify what kind of val throughput you need, what is the storage layout, what level of IOPS do you require. So those are a couple of things that you need in order to determine the SKU size. And the starting point of that would be to analyze the AWR report from Oracle. So if you're running Oracle workloads, then you can get the AWR report during the peak workload times and identify what's the IOPS requirements, what's the CPU utilization looking like. And those are basically clues for you to determine the right SKU size and plan the target architecture in Azure. And once you have the schema converted, then it's about loading the data. And loading the data would be done through either you could use Azure Data Factory, tools like Azure Data Factory, which is a first-party service to load data in Azure. It's a cloud-based ETL tool, or you can rely on other tools in the market like Stream, which you can use to load data in parallel. And here you could leverage the partition-based data loading as well. So if your Oracle tables are partitioned, and in Postgres, when you create the tables, you create them as partition tables, and then you could load the data in parallel into those partitions. That way you can load the data faster. And if you need a low downtime migration, then in that case, you would use tools like Stream, which do real-time or near real-time replication from the source to target. And that can help you keep the source and the target in sync for an extended period of time. And after you're done with that, you basically do a round of validation, performance testing, and then tune the queries which don't perform the way you want it to. And then once you're done with the tuning and testing, you basically cut over to the new environment. So that's how a typical migration looks like. Some of the important points to consider when you're doing large database migrations. So first of all, like I said in the initial bit, as the data grows, the complexity also grows of the database also grows. So something to keep in mind, if you have a huge amount of code in your database, then obviously you need to factor in that time so that you are able to migrate it across. The other thing is the partitioning. So if you have a lot of partition tables in Oracle, you probably have to redesign the partitioning strategy in Postgres because the partitioning strategies are very different in both of these database engines. So keep in mind and ensure that you define this before your migration so that you're aligned with respect to partitioning. Because once you change the partitioning, there is a possibility that some of your queries also have to be tuned and changed because the partitioning strategies are quite different in both of these database engines. Another challenge that we keep witnessing is lobs. I mean, if you have a lot of lobs in your database, then that is going to be a challenge for sure, because transferring lobs is going to take a lot of time and it is not efficient. So the right way or the best way to do this would be to run a query, find out how many lob tables you have in your DB and keep them separately and migrate them separately and define a strategy to migrate them separately. A good thing about migrating to Azure would be see if you can move those lobs to an Azure storage rather than storing it in the database itself. That is one good mechanism to also re-architect in a way or redesign your application efficiently. So because once you move those lobs to an archive storage or a storage outside of Azure, then your database size is going to be smaller, your backups are going to be faster, your queries are going to be more efficient. So think about that. If there is an opportunity to do that change, then go for it, because that's going to help you make your queries go faster. And the other important point is val generation. So you need to ensure that you take in account for this and tune it accordingly, so that you are in the right SKU in Postgres. Some common pitfalls when it comes to VLDB. So as the data size grows, the table size also can grow, so which can lead into table bloat. As you know, Postgres follows an MVCC pattern, which means that it keeps the old version of rows in the table, and this can lead to table bloat. And having a bloat in the tables, which means that your queries are going to be slower, and it is going to cause performance issues. So keep in mind, when you have a large DB, if you have ingestion processes which can cause this, then ensure that you avoid the table bloat. One of the other things is auto vacuum, which can be stalled. So in order to clear the table bloat, the vacuum process has to run periodically. You need to plan this so that your maintenance tasks run efficiently. So these are a couple of challenges which is quite common when a database is large. Slow copy performance can also be one of the other things which customers usually don't pay attention to. So if you have ingestion processes which load data in bulk, think about using copy. Think about tuning the copy performance. That's something that you have to keep in mind, because this is something that is overlooked repeatedly. And the last thing would be SKU sizing. So sizing the compute according to your workload pattern is very important when it comes to a large database, because you cannot have a 4 vCPU machine running heavy queries on a 20 terabyte or a 30 terabyte database, which is not going to be efficient. So you need to size it accordingly so that your workload is able to perform efficiently, and you need to ensure that you size it based on AWR reports at the beginning of the exercise, and this needs to be done during the performance testing. So those are a couple of pointers which you can take from this session and ensure that you follow these tips. So if you are migrating large databases, because these are very helpful, so that you don't run into common overlooked issues, and you don't run into problems when you're migrating databases. So I'll leave these links in the description, and I'll share these links later on. So these are quite useful links if you are migrating from Oracle to Azure Database for Postgres. I'll share these links in the description, and you can have a read offline in case you're planning to migrate from Oracle to Postgres. Thank you for attending the session, and in case you are interested to know more about Oracle to Azure Database for PostgreSQL migrations, or if you have a topic for discussion, feel free to reach out to me. I'll be happy to discuss. Thanks for joining the session.
Okay, that was a great talk, and the Discord chat is full of migration horror stories.
It's hard work.
Okay. Again, do the survey, get your socks. It's the best way to get them. They are one size fits many. I keep seeing more and more people at conferences in our socks, Thomas.
So next up, we wanted to take a moment to talk about Livestream 4. So there were four live streams in this conference. Livestream 4 is same time tomorrow. Do I have that right? And
I believe so.
Yeah. So we're going to see a trailer for that.
Hi, my name is Derek van Veen. Today I will be talking about Postgres partitioning. This is my Postgres partitioning cookbook based on the past 4 years I've been building this experience with Postgres partitioning. If you are working with Postgres and you need to start with partitioning, this is a really good starting point.
Hello, I'm Ashutosh Bapat. SQL PGQ is the latest addition to SQL Standard. It allows relational data to be treated as if it is a graph. We have committed basic support for this standard in PostgreSQL 19. In this talk, you will get familiar with salient features of SQL PGQ standard and what has been committed recently.
Hi everyone, I'm Rahila Sayed. I'm here to talk to you about a topic titled Journey of Developing a Performance Optimization Feature in Postgres. It is an exploration of how one can develop a feature which will improve performance of physical replication. This talk will be useful for developers who would like to contribute to Postgres or anyone who would like to learn more about physical replication.
Hi everyone, I'm Nitin Jadhav. I'm a senior software engineer at Microsoft and I work for the Azure database for PostgreSQL team. The talk you're going to watch is about PG-DuckDB in action, accelerating analytics on Azure database for PostgreSQL. If you have ever wished your Postgres database could just answer an analytical query faster without you first exporting data somewhere else, then this talk is for you. By the end of this talk, you'll know exactly how PG-DuckDB makes that possible, and you'll see it running live on Azure database for PostgreSQL Flexible Zero.
Hi, I'm Xuneng from .NET Foundation. Have you ever deployed your Postgres database and other cloud services to the public cloud service? So sometimes you may have this question. Can I actually performance testing our infrastructure before we actually deploy it on the cloud? Well, today in my talk, I'm going to show you how we can use discrete event simulation to do the shift left performance testing on our infrastructure before we even deploy it on the cloud.
Hi everyone, my name is Hari Kiran. Today we are going to track the full arc of logical decoding and replication. We'll go from its earliest building blocks in PostgreSQL 9.4 all the way to the multi-master distributed future that's being actively built right now.
Hi everyone, my name is Sakshi Nasha and I'm a software engineer at Cohesity. Today we're going to talk all about security in Postgres. Is your Postgres really secure or is it just working? Are you thinking of security as a design habit or just thinking it as an afterthought after you launch your product? So if you have security in mind and Postgres, this talk is for you.
Welcome everyone, my name is Shashikant. Today I'm going to talk about what I think is the most exciting area of improvement in PostgreSQL 18, vacuuming. If you ever dealt with the PostgreSQL database in production, whether that's on Azure, on-premise, or anywhere else, the changes which we're going to cover today directly affects how your database handles bloat, freezing, and overall maintenance.
Hi, I'm Mohammad Osama, and I'm going to talk about Citus cluster scaling. The recent version of Citus landed 2 new enhancements in this area, and I'm going to talk about both of these, how you can leverage those and what they are all about.
Hi there, my name is Jimmy Angelakos, and my talk is titled Listen Carefully, How Notify Can Trip Up Your Database. And it is a real world story. It's a thing that happened in production once upon a time, and it's a real pitfall and situation that can be caused when using this mechanism in Postgres. So I think it's really useful to talk about it and show you what it can cause and also how it can be fixed.
Hello everyone,
My name is Hamid Akhtar, and today I'm going to talk about where does my insert go, a logical replication story. In this talk, we're going to start with an insert from the publisher to the subscriber database. So if you're planning on understanding the workflow of how logical replication works, this talk is for you. It will give you all the details about the wall, the logical replication, the decoding, and take you from the publisher to the subscriber.
Great lineup so far. Like, I'm looking forward to some of the talks, like most notably Muhammad Usama talk about Citus cluster scaling, not surprisingly, I think.
Yeah.
But I also saw some interesting ones on vacuuming, logical replication, and I'm curious about the war story on listen, the notify.
I'm also really looking forward to the talk on SQL PGQ, the graph theory stuff. It's really interesting to see all of the people who are tracking new standard SQL features actually following the standard, which is kind of what Postgres is supposed to be about, right? So yeah, great to see recent features coming into the product. So.
Yeah, and the hallway track is very lively today, so please join it. Participate in the conversation, share your horror stories or cool stories, whatever you prefer. And the next talk that we are going to see is by Bishert Yen, who works at Microsoft. He's a senior software developer at Microsoft. And we will learn about PG stats, which is what really decides how the database is executing your query. So like, is it a sequence scan, a full scan, and how statistics impact all of this? I'm looking forward to it. Let's see it rolling.
Hi, everyone. My name is Richard Yen. I'm here to talk about PG stats and about how Postgres and statistics work internally. It's a talk that's geared towards beginner and intermediate users, people who want to get an idea of how Postgres internal statistics operate and how it influences the query planner and how to improve their performance on some of their queries. All right, let's get started. We're going to talk about PG stats and how Postgres internal stats work. So many of you guys probably have experience working with simple queries like this easy one right here. Select star from customers where state equals California. Very simple. And, it's a table with customers and some information about the customer. And it's probably going to be, for simplicity's sake, we're going to make it very simple like this. So ID column, city, state, and the sign up date. And we create this table. We insert 1 million rows just to make sure that it might represent maybe the product that you're trying to work with. And we will have a index on both the city and the state column, as well as a sign up date. And if you have an index, we are most likely expecting that index to be used. However, when you run this, maybe you'll experience something like this. You'll see a sequential scan on customers, and you start wondering why. We run it again, and it's still a sequential scan. We do an analyze, we try to do whatever dance we can do with the database, and it's still a sequential scan. Now, you might be tempted to think that something's broken, but it's actually working just fine. And we're going to talk about that today during our talk here. The key point is that the query plans that you see, for example, like this one, these query plans, they are made by something called the query planner. Many of you are probably familiar with this, but I just want to reinforce this to you, especially if you are new to Postgres or just getting more deep into using Postgres as your database of choice. So this is the kind of layout that we would expect, or what we would see that your data lives in a customers table. And when you select stuff, you're going to get data out of that customers table. However, when the query planner does the query planning, it doesn't actually use the customers table right off the bat. It actually gets statistics out of the PG statistic table, and that table is what gives the query planner an idea of what kind of query plan what kind of plan it should use to actually execute your query. The the PG statistic table is actually basically like a summary. It's got a bunch of statistics about the table, the columns, some of the ranges, most common values, stuff that it could be that could be useful for the query planner to make that plan. And just to point out, the PG stats that we're going to talk about today is actually a view of PG statistic. So PG statistic is the table, and PG stats is a view of it. The reason why is because the Postgres community that developed it, they wanted PG stats to be more PG statistic to be more human readable. And when you look in PG statistic, if you do a select star, it's actually not going to be very useful to you. So using PG stats is going to be your way to get an idea of what the query planner sees when it makes a query plan. So a quick aside, a little bit of Postgres trivia. So if you have a table that has a plural, like PG stats, or if you have a table or a relation that is has the word stat in it, so like PG stat, user tables, PG stat, user indexes, those are all actually views, and they're not actually tables. The ones that are in the singular form are usually the tables. And you can see that if you want to run this query in PSQL, and you'll see which ones are views and which ones are actually tables. All right, so that's just a quick aside. So how does PG statistic get populated? The way that happens is when you manually run analyze. So when you say analyze customers, it actually kicks off a process that scans your customers table, pulls all together all those statistics, and gets that summary into PG statistic. So we're going to go through a simple example to kind of highlight what that looks like under the hood. Okay, so once again, we have our table, customers, we have our 4 columns, and we've inserted our million rows. We have our indexes, we have our, we run our analyze. What happens? So when we actually look in PG stats, so I just pulled 4 of the columns out of there. Attribute name, which is the column name of the table, ndistinct, nullfrac, and correlation. So ndistinct is actually the number of distinct values within that table. So within that column, I'm sorry. So for example, like my customers are all based in the United States. So if I look at the number of distinct customers, distinct cities within that customers table, I'm going to see something like maybe 10,106. That's pretty reasonable. It's realistic. I'm going to see 50 states, which is lines up with reality because there are 50 states in the United States. The null frac column is actually the fraction of rows that are null. And in this case, all the columns are not null, and the primary key cannot be null. So therefore, null frac is going to be 0. You might be wondering what the ID, why is it -1? So because every row in that table is unique ID because it's a primary key, there's going to be the number of distinct values is going to be the number of rows in that table. So that's why Postgres lists it at -1. For correlation, this is actually pretty interesting. So when the analyze process pulls the data out of the database, the table, it assigns a correlation, and this is a statistical term. It's going to be between -1 and 1. And the value of that actually affects whether or not the index scan gets selected. So for the way that it's calculated is basically like looking at how much data is on the disk. If it's randomly spread out, or if it's lopsided in one direction or in the other, the value gets assigned. So if it's going to be 0, it's actually going to be very randomly spread. So in that sense, it would not want to choose an index scan. It would prefer to do a sequential scan. So it's kind of like a penalty counter. So if the closer it is to 0, the more likely it's going to choose a sequential scan. The closer it is to the extremes, -1 and 1, the more likely it's going to want to choose an index scan. That all gets multiplied. There's a lot of math involved, and I won't get into that because this is kind of more of a introduction to PG stats. There's more information that's available online on the documentation. So if you want to look there, that would be a great place to start. Moving on. So let's actually look at some of the values that are in the PG stats table. So there's a column called most common values, and most common frequencies. These are both arrays. So let's say you have a value of California, which is the first element of the array. The frequency in the most common frequencies is in that first value is going to be the frequency of the occurrence of California. So I'm pulling all that out and putting it into a table form here. You'll see that California's frequency in the table is about 17.4%. And in Texas, it's about 11.65%, and so on. So as you can see, the query planner gets these information. So if California shows up in the query, I want to select star from customers where state equals California. I'm going to know that about 18% or 17% of my table is populated with the state of California. And from there, you can make some calculations. So I'm starting to talking about calculations, and the calculations are actually based on something called cost. So the cost of using an index scan or cost of using a sequential scan, all of these things are mathematically computed so that the query planner can choose, hey, it costs this much to do this, and it costs this much to do this other thing, and I would rather choose a cheaper one. The three costs that we would want to focus on, there's a few other ones that are a little more nuanced, and I won't get into those just yet. I think these ones are the ones that most people are most interested in. So random page cost is the cost of pulling a random page out of the disk. So if I did an index scan and I find my value California and it says one of the tuples is in this page in this table, then I'm going to go randomly pick it. I'm going to go fetch that page out of the table, and that page fetch is called a random page fetch. So the cost of pulling that random page out. The sequential page cost is if I started at a particular place in the table and I pulled the page out and then I pulled the next page out and I pulled the next page out, that would be what a sequential scan does, and it basically costs that much to do a sequential scan. The CPU tuple cost is the cost of using the computer or the CPU to pull that tuple or that row out of that page. So I've done some page fetches, and now I have the pages. I want to pull the tuples out. How much does that cost? So these are all tunable, and usually there are many guidelines online that we can reference that can help you based on your hardware and your setup, what the cost should be. And that will be for another talk or exercise. So based on these costs, the calculation affects many different things for the query planner. It affects whether you choose a sequential scan, index scan, bitmap heap scan. And then when it comes to joining tables like the customers and orders tables, if you join those two, should I use a nested loop? Should I use a hash join or a merge join? All of these are calculated, and from those calculations, the query planner decides, I'm going to pick the cheapest one, and I'm going to execute it. So I'm going to move on and show you an example of how these cost calculations might affect the outcome of a query. So just like we started off with, we have a select on customers where state is California, and we have a select on the state of Wyoming, and we'll see how that gets affected by the costs. The output of the select on California, we see that the sequential scan, it costs about 19,000. The units are kind of, there's not real units, it's just the cost of a query. Now we know that there are 17,000 rows estimated in the table, And then when it actually did the sequential scan, it found 17,200 rows, which is a little bit less, but it's still within the same ballpark. Now you can see that if I had 1 million rows and 17 or 18,000 of those rows are California, it's about 20%, right? Yeah. So if you think about the idea that I'm going to do an index scan, I'm going to scan through my index, I'm going to fetch a page, and then I'm going to fetch the tuple out of it. I'm going to move on to the next one, fetch another page and pull the tuple out. And you're going to do that 17,000 times in your 1 million row table. That could actually take a lot of time and CPU cycles. So it might not be very useful to do index scans. So therefore, the query planner decides the sequential scan might actually be more efficient. Now imagine, let's blow this up a little bit more. Let's say 900,000 rows have state of California. To fetch every entry in the index, you're going to end up scanning almost the whole table anyway. So you might as well just scan the whole thing. So hopefully that helps you understand and illustrate why the query planner chose to do that sequential scan, even though it was 17,000 and 980,000 were still not the same value. Okay, so let's move on to the Wyoming example. Now, the Wyoming example, we only have 4,000 rows, right? So 4,000 rows, that is a significantly smaller amount of rows in the database or in that table. So the query planner does a cost calculation and concludes, oh, 13,000. It's a bit less than 19,000. So I'm going to use the index scan now. And that's why it chose that. Now you can ask, okay, how do I know if the query planner actually calculated the right cost? Like, how do I know that it's actually 19,000 and that's actually the fastest one? So what we can do is we can trick the query planner to say, hey, let's try really hard not to do the sequential scan. Let's try to encourage it to use index scan. So what we do is we can temporarily set enable sequential scan to off. And when we do that, we basically tell the query planner, hey, let's try very hard not to use this. Okay. And now when we actually do it, it does an index scan. And you can see that the cost here was 32,000. So it actually computed the cost that it takes to fetch a page out of disk and all that stuff. And it decided, it calculated, hey, 32,000 is significantly higher than 19,000. So that's why the sequential scan is better. Okay, so just basically to wrap up that idea, the most common values list, it really helps the query planner choose that sequential scan. When that data is skewed, you have a lot more values of California versus very few values of Wyoming. All right, so let's move on. So we talked about most common values, and let's talk about histograms. So histograms are basically graphs of the frequency of a particular value or a particular range of values. So where state is equal to California or state equals Wyoming, those are equality. And that's pretty easy to get out of the most common values. But what if you wanted to look at like a range, like the customer signed up before January 1st of 2026, right? So that range is going to require a different kind of statistic, and the histograms is what helps you with that. Okay, so here we go. We're talking about histograms, and so the boundaries, right? So by default, Postgres will actually collect 100 buckets worth of information for a particular column. So in this particular example, the sign up date, we have 100 buckets, and each of those buckets roughly comes out to about 2 months worth of data. So January to end of February, beginning of March to end of April, and so on. So this is good if your table is small or if you don't have a lot of variance in values. And I'm going to share with you this illustration of a histogram with low precision. So we have 100 buckets. In this picture, there's 5 buckets, right? 5 buckets from roughly about 5 to 32, and then 33 to 48. Now, this is pretty, I mean, I think it captures reality pretty well. I mean, most of your values are between like, I don't know, 48 and 63. But what it doesn't capture is the finer details, right? What's your actual most common value? Or what if I wanted a smaller slice, right? So if you look on the picture on the right, the histogram has a lot more buckets and a lot more precision. You can actually see how low, how infrequently the value of maybe 69 or 70 appears. This kind of curvature won't get captured in that picture on the left. So how do we get more precision in our queries? Well, the way that we do that is by changing the statistics on that column. And the way we do that is by altering table customer and altering the column, setting the statistics from 100 to 1000. So when we do that, we actually are now have 1,000 buckets, and each bucket actually, instead of 2 months, it represents 2 days. And this is actually going to be a lot more precise, and you might actually get a better query performance because you have better statistics to decide what to do. Now, one thing I want to highlight is that there are trade-offs, right? Because when we have more buckets and you do an analyze on the table, you're going to actually have to spend more time populating those values in that histogram, and you could end up with your analyze taking a long time. So that's why I would encourage you, if you need to change your statistics, do it on a table column by column basis, not on a wide scale. Now, I would like to move on to correlations, which is something that I think is actually very important and some people might overlook. So when we are talking about our states and cities, right? So I want to select all the customers where city is Cheyenne and state is Wyoming. And you're going to get an index scan, which is great. But sometimes it might not be the right scan. So if you look at the row count there, what the query planner thinks is in the table that has city equals Cheyenne and state is Wyoming, it thinks that it only has 8 rows. But when it actually runs, the actual rows is 4,000, because every city in that table that is Cheyenne actually happens to be with state Wyoming. The reason for this is because of simple statistics, right? The probability of choosing a city called Cheyenne and a probability of choosing a state in Wyoming, you multiply that permutation together, is the probability that you're going to get both of them in one row. Now, we know that in statistics, that might actually work, but when they're actually correlated, that doesn't work, because everybody knows, everybody who grew up in America knows that the only city in America called Cheyenne actually happens to be Wyoming. So when you select for Cheyenne, you're pretty much selecting for Wyoming. A quick aside, I mean, there's actually one other city in Oklahoma called Cheyenne, but it's actually population 700. So it's a very small city. I don't think that's going to affect our statistics here. But yeah, so the way to resolve that and to make that correlation, to make that connection, is by using the create statistics command. This is a feature that's been around since Postgres version 10. And the way that you call it is like this: create statistics, and you name it, and then you want the statistics types. So we want dependencies and distinct, and you analyze the table right afterwards. The statistics type, you can definitely read more about that if you're interested in the documentation. Now, when I actually run this again, you'll see that the estimate is a lot more close. It's 4,087 instead of 4,012, but that's a lot closer than 8. So while this example might not demonstrate that, if you have a large query which joins many tables and has a lot of correlation, you could run into the situation where one of these index scans, if it's estimated incorrectly, it'll affect the joins, the other scans upstream in that query. So we do want to make sure that our row counts are correct.
So just to sum it all up, when you are dealing with queries, sometimes if it's slow and it's not behaving the way that you want, I have 6 steps that you can actually try to follow. So the first one, compare your estimated versus actual rows. So run your explain analyze, compare the estimated rows and the actual rows, and look for the deepest node. So if you have several joins, several tables that are involved, look at the very end of it and work your way up. Look for the ones where the estimate doesn't match with reality and see if you can resolve it there somehow. One way to resolve it is by checking your PG stats for that column. Look at the end distinct, look at your most common values, look at your histogram. Do those values match with what you know about your data? So for example, in my example, the number of states, like if it says only 1 state, or if it says like 700 states, maybe that might be incorrect and might need to deal with it somehow. Now, if the stats look a bit stale, like maybe if it's like sign up dates, or if it's some other value, maybe you should run analyze. And I think this is especially true after a large batch load or migration, when more information is coming in and the statistics hasn't really caught up on it. The reason why the statistics might be stale, it could be because auto vacuum or auto analyze hasn't caught up, gotten around to that table to analyze it for you. So you might need to actually manually analyze it. Estimates are still off. Maybe you might need to increase the statistics. Like I mentioned earlier, Postgres by default captures just 100 buckets. You might need to increase it to 1,000 or more. I think you can go up to 10,000 if you need to. Now, if there's a bad estimate that involves 2 columns or more, maybe consider the fact that they might be correlated. So you'll need to create extended statistics on that on those columns. Now, if all of those 5 steps of investigation don't seem to improve your query, after that, then you might want to consider maybe rewriting the query or looking for other ways to improve the query performance. So that wraps up my talk. I really want to drive home the point that the query planner is only as smart as the statistics that you feed it. So definitely be sure to keep those statistics accurate, analyze often, make sure you check and make sure those values are within reasonable ranges. So really hope that you learned something new or got a lot out of this talk. And thanks again for joining us, and hope you enjoy the other talks at Posette.
Oh, thanks very much, Richard. A great introduction to statistics. It's a pretty important thing to understand, because databases have to choose from, relational databases have to choose from huge numbers of possible plans, and that's all they have to do it. So
yeah. And it's a very live thing, right? Like data changes over time, and you can be very surprised by, why does this query suddenly do something completely different?
Yeah, well, that's true. Well, there's some really interesting stuff coming into Postgres 19 to deal with pinning plans down, which is interesting stuff that people ask for all the time when they move from other databases, which we traditionally didn't have. But yeah, understanding what those statistical values mean and how to tune them. I mean, I thought it was a great starting point for a problem solving list, and I've personally seen create statistics solve real world problems many times. For example, the correlation example. So cool.
Yeah, definitely a must watch. Okay, so again, socks proxy, go fill the survey, get your socks, walk with them, go to the next conference near you in those socks.
And swag. We'll send it to you.
Yeah. Don't forget the stickers. We have plenty of cool stickers.
All right. So next up, we're going to hear from Xuneng Zhou, who's going to be talking to us about hacking on Postgres, which I'm really looking forward to seeing. I've interacted with Xuneng many times on the hackers mailing list, and be great to see his take on the experience of dealing with the rabid Postgres developer community.
Yeah, let's grab a towel.
Hi, I'm Xuneng. In this talk, I will share a practical path for getting started with Postgres hacking. And we will look at why Postgres hacking feels differently and how to start small and how small compounds over time. If you are interested in Postgres hacking, then this talk is for you. Okay, let's move to the title of this topic, The Hitchhiker's Guide to Postgres Hacking. It's all about hacking. And from this talk, we can learn that we should not be panic about Postgres hacking. We can just start small, and small will take you to where we want. Every journey into Postgres hacking starts with mixed feelings. There is excitement, curiosity, but there is also self-doubt, uncertainty, and confusion. And this is quite normal. From the outside, Postgres can look finished and intimidating. But from the inside, it is still a living engineer project where people ask questions, revise patches, and change their minds. Hacking Postgres is pretty hard. And this is why motivation matters. The code base is massive and complex. So even finding where to start can be hard. And the review process is rigorous and hypercritical. And finally, the database technology itself is quite difficult. As we know, optimizers, transactions, and concurrency control, these are very hardcore technologies. Even it's hard, people still want to do it. And some people may do it for fun, because hacking is generally fun if you like logic, reasoning, and building large things from pieces. Some people do it for the community. If you make one small change, whether it's documentation or test, it actually helps all users. And sometimes people do it for profit, because Postgres is the database for the future. Actually, these motivations are not mutually exclusive. You can enjoy the technical challenge, help the community, and build professional value at the same time. So, let's go on tour. The tour starts from a simple idea. Do not try to understand everything first. Start with something small enough to finish. Start small to build confidence and familiarity. One good starting point is reviewing patches. Reviewing patches help you generate ideas, learn the community thinks, and build connections with the hackers. Another starting point is fixing bugs. A small bug fix is usually self-contained and easier to follow. A third starting point is actually to test the features that other hackers work on. The common pattern is all three passes give you a concrete object to study. This patch, this bug, this test failure, or this behavior. So my first practical recommendation is start from reviewing patches. Contributing a new feature to Postgres can be hard. So begin by reviewing existing code. You get familiar with the Postgres hacker community. Learn explicit coding standards and learn unwritten communication norms. A useful review doesn't have to be perfect. You can report the patches builds, test the corner case, point out a confusing error message, or ask whether a behavior is intended. So how to get started? First, go to the Postgres mailing list page and subscribe to the hacker list. The hacker mailing list is the place that the hackers live, where the discussion happens and the debate happens, and the patches are reviewed. At the beginning, you don't need to reply to everything. Just read and watch how people structure arguments, notice what kinds of evidence are persuasive. Test results, reproducible examples and benchmarks with clear workloads. Then pick a patch in Camillifaced that interests you. Camillifaced is the unique way of Postgres manage its review queue. Contributors submit patches there, and the reviewers help evaluate correctness, design, test, and code quality. Actually, you don't need to pick the largest patch. Just pick something with clear scope, where you can say, oh, I understand what it's trying to do, and I can test whether it does that. The practical review workflow has 4 layers. First, build and test the patch. Usually, you can make a check. And secondly, you can check the behavior, usability, and error messages. Thirdly, sanity check performance and concurrency. Fourthly, review code style, architecture, and documentation. I think that the orders actually matters. Start with basic reality checks, then move up toward to design and maintainability. Build and test prove that the patch survives baseline reality. Run make check against the existing and new regression test. When you report results, be precise. Say which branch, configure options, and test command you actually use. If something fails, including failing test name and important error output. Next, you can check behavior and errors. Ask whether the patch fulfills the original design or solves the original problem. Ask whether the API or command line interface feels intuitive, or whether it is overly complex. Look carefully at error message. Postgres should produce clear and helpful errors. And this is actually a fresh reviewer can be useful. Try invalidate inputs, pondering values, and a different order than the happy path. Ask whether a real user will do and what happens when they make a mistake. Then you can look at performance and concurrency. For performance, you can look for algorithmic bottlenecks and inefficient memory handling. Use benchmarks and tools like perf when change is performance sensitive. For concurrency, you can audit shared state, lock durations, wake-ups, and deadlock logs. For a database, performance and concurrency are part of the correctness in practice. Even if you cannot do a full benchmark, ask what hard path is and what shared state the patch touches. Finally, look at architecture and documentation. Ask whether the logic belongs to this layer. Ask whether the function or module and whether the text exercise the new behavior. Documentation also matters. Undocumented code becomes legacy code at the moment it merges. And architecture review is difficult because it requires taste and context, but you can still start with simple question. Is this duplicating an existing mechanism, or does the text describe the user behavior? Does the documentation explain the semantics? Okay, now I want to move from general advice to one concrete review journey. This journey starts with broadening the mailing list. The topic was implementing waiting for else and replay. At first glance, this is a very specific feature, but it's a good example of how a small review path can lead to real Postgres internal workers. So in the second half of the talk, I will use this example as a guided walk through how review becomes learning, and we will start from the user visible problem, then look at older pooling solution, then look at why pooling is more expensive than it appears, and finally look at how feedback from other hackers changed the design of the command. Okay, the problem that this patch and feature try to solve is read after write consistency in asynchronous settings. Imagine a user writes a comment to the leader, gets an insert success, then reads from the follower. Because replication is asynchronous, the follower may not have replayed war records yet. So the read can return no results, even though the write has actually succeeded from the user's perspective. In this diagram, the user inserts a comment, the leader accepts the write, and the later read is routed to the follower. If a follower is behind, then the query can miss the row. The database may be behaving correctly, but from the user's point of view, it looks like the system lost the write. Here is the basic architecture of streaming replication. On the primary, the backend modifies the table and writes war. The war sender sends a read war and sends it to the replica. On the standby, the war receiver writes the war and the startup process replaces it into the table. But in asynchronous settings, the backend can return success after war has been flushed locally, but before the standby has replayed it. This means there are several different positions to think about LSN positions: generated, sent, received, flushed, and replayed. These are related, but they are not in the same guarantee and at the same time. For read after write visibility on a standby, replay is the key point. Receiving and flushing war is not enough. You need to waiting for the replay to let the table actually applies the record. Before wait for SN, the usual solution is pooling. The application obtains the target SN from the war insert SN function on the primary. Then it pulls the standby using PG last war replay SN to reach that target. This works, but it can be very inefficient. The attraction of pooling solution is that it's easy to implement outside the server. You do not need a new circle scan command. You also do not need to wait infra. You just write a loop. But the cost of that simplicity is paid repeatedly, and it pays in places that are not really part of the core problem. The core problem is only a comparison between the target SN and the standby's replay progress. Pooling turns that into many SQL round trips, asking the same question: have you reached this SN yet? The pooling solution is quite simple. You get a deadline, repeatedly query PG last war replay SN function. If the standby is not ready, continue. If the replay SN is greater than or equal to the target SN, return success. Otherwise, sleep and try again. The problem is that simplicity at the application level pushes repeatedly work to SQL execution, connection management, and wake-ups at kernel level. And this overhead has two parts. First, every pooling solution at another query and compare SN. Then the system pays extra circle execution, connection, and network cost. Secondly, there is a latency versus load trade-off. Short pooling intervals give faster responses, but increase the system overhead. Longer pooling intervals reduce this workload, but increase the latency. The myth is that the pooling is cheap because the war replay LSM function is just a simple metadata read. Actually, the reality from low level is quite different. In the profile here, we can see that the actual SN check accounts for only 1.6% of the CPU time. And the remaining cost is the machinery around it: PR, PGSQL, SPI, the executor, and the kernel wake-ups. The primary drivers of overhead are not the LSN comparison itself. There is interpreter tax, SPI plumbing, plan validation, snapshot work, This is why a server-side wait primitive can be much cleaner than the client-side polling. The detailed CPU profile makes this visible. Other functions take much more time than the actual PG_WAR replay function work. And that is the key point. The useful check is small, but the repeated execution framework is quite large. With wait for SN, the flow is more direct. First, update the primary. Second, capture the wall insert SN. Third, on the replica, wait for that SN. And fourth, after success, itself to read because the change is actually replayed and visible on the replica. The application expresses the real intention. Wait until this wall position has reached. The SQL example looks like this. On the primary, update the movie table and then call pgcurrent wall insert SN function to capture the SN. Then, on the replica, run wait for SN with the specific SN you captured from the primary. When it returns success, the application can read from the replica, knowing that the relevant change is visible. After wait for SN, the system avoids the actual expiration evaluation cost of repeatedly pulling. It avoids high-frequency clock checks in the application loop. Instead, the backend can wait and sleep using the server's own wait infrastructure. The intention is simpler, and the resource behavior is actually better. The point is that waiting for replication progress is already a database state transition. The server tracks the relevant progress, so the server is the right place to wait efficiently for it. As we can see from the hardware matrix show, in this workload, pulling or waiting for target replay SN occurs at about 10 seconds interval. And the PG18 pulling path uses much more CPU work than the PG19 waiting path. As we can see, cycles about 10 times higher, instructions about 5 times higher, and the catch misses about 7 times higher. And the task clock is about 3 times higher. And with PG19 wait for SN infra and the command, we actually reduce the numbers significantly. And this reveals that removing pulling removes a lot of repeated machinery. For review, this kind of evidence is powerful because it connects design to measurement. It gives other hackers something concrete to evaluate and challenge. It's also important to describe the workload honestly. But it also shows that shape of the cost. The polling path repeatedly pays for general SQL machinery, while the waiting path avoids much of that repeated work. So you need to write emails to explain and summarize this clearly. But the technical side idea is only part of the story. A Postgres hacker also changes through feedback. Actually, the reviews from the other hackers of the community helps the patches from very close state into the state that can be committable. So the next part, we're talking about how to take in feedbacks from others help shape the patches that we are working on. One piece of feedback for this patch is that the command needs timeout and no trivial options. And this actually makes sense because applications need to control how long they are willing to wait, and whether a timeout should raise an error. But then the grammar becomes a problem, becomes a design question. what should the option list look like? And this is where the community feedback shapes the interface. What we end up with this patch is using a common pattern in Postgres development. Is with the option list. And Postgres development may begins with a good implementation idea, but the review turns to better user interface. And the grammar matters because SQL syntax is long-lived. Once users depend on it, it becomes hard to change. So the project is very careful about names, defaults, and extensibility. Another design input from hackers for this patch was to add a mode option to support weaker consistency guarantee. At first, wait for SN only waits for replay, but hackers point out that some users may want wait for war to be received or flushed instead of fully replayed, and this is called weaker guarantees. And that can be useful for clustering systems or applications with different durability and visibility requirements. And this feedback changes the abstraction boundary. The command is no longer wait until visible on the standby. It becomes wait until SN reached the selected progress state. And this is broader, but is still bounded. So the command can be extended with a mode option. The patch supports waiting for an SN to be replayed on replica to achieve read-after-write consistency in asynchronous settings. But it can also offer less strict guarantees, such as waiting for word to be written or flushed on the replica. This keeps the main command general without inventing separate commands for each level. And this is actually a good example of being open to feedback without losing the original goal. The original goal was a read-after-write consistency. The feedback did not remove that goal. It actually clarified that replay is one mode among several useful waiting mechanisms. A better design can preserve the main use case while making room for adjacent use cases. Now, let's look at the syntax of the new mode. The syntax becomes wait for SN with mode. The default mode is standby replay, which waits for word to replayed to the specific SN. Standby write waits for word to be written or received on the standby. And the standby flush waits word to be flushed and disk on standby. And the last one, primary flush, waits for word to be flushed to disk on the primary server. So these are the lessons learned so far from my hacking journey. Start small, but aim big. Be confident and persistent, and be open to feedback. As the Paul quote applies here again, knowledge expands fractally. And from a distance, its edge looks quite smooth. But once you learn enough to get close to one, they turn out to be full of gaps. So small work can become big through compounding. So this is the end. Is this the end or the beginning? For Postgres hacking, I think it's always the beginning. Start with a simple review, a bug, a test, or small patch. Follow the discussion, learn the nearby code, make the knowledge compound. And most importantly, do not panic. Just small. Thank you.
Great talk. Thank you, Xuneng.
Great talk. It's always hard to start, right? Like you have to learn what to do, how to approach. Some of the things in the community are maybe daunting to newcomers, right? Like using mailing lists and things like that.
Absolutely. also you write an email and you think it's something like some of the things that Xuneng was talking about, and you think that it's, the people you're interacting with may already have looked into the subject, or may already have a lot of opinions, or there may already have been 7 previous arguments about this topic that frizzled out or something. So yeah, it's a complicated business, but persistence. Yeah, great presentation. Thank you.
Yep. Yeah, and if you have questions, go to our Discord. You can find most of the speakers there during the hours that their talk is aired, or longer. And also the socks proxy. Get your socks and go to a conference near you. And also, I keep talking about the socks, but actually the most important part is do the survey. Give the speaker some feedback on how he did, or how they did, what they should improve, or what was great, what motivated you from the talk. Okay. And next up is a colleague from my team, Murat, who will talk about tokens of, from trust to tokens, short history of PostgreSQL authentication. Murat has tons of experience working with Citus at Microsoft and across at least 2 live services, I think. Let's see it going.
Hello, this is Murat Tuncer. I'm going to talk about PostgreSQL authentication, that is from trusted tokens and short history of PostgreSQL authentication. It is about how PostgreSQL authenticates your connection. I'm not going to rank methods. I'm just going to explain why each authentication method exists and how you can choose between them. Let's move from trusted tokens. First, about myself, I told you about my name is Murat Tuncer. I'm software engineering manager at Azure Database for PostgreSQL Service, where we do distributed PostgreSQL services. I was previously at Citus Data, where I had a chance to work on PostgreSQL extensions named Citus and the C-Story FTW, that is columnar extension. I also worked on distributed PostgreSQL service back then called Citus Cloud. Okay, let's go next. So this is the problem, pghpa.conf, where all PostgreSQL authentication happens. And most users only see this once, maybe more, but mostly once, when something fails. And they open the pghpa.conf file and they discover PostgreSQL has roughly a dozen of authentication methods, not one, and there are many, and it may look confusing in the first. But the line you see on the screen is the most modern cluster ends up with. So let's dive in and see where that came from. So this talk is about authentication methods, but these questions, I'm not going to answer those questions. I keep getting those questions myself, and sometimes I ask those to myself either too. But the honest answer to all those questions is the same: history. Every method you'll see on the pghpa.conf file solved a real problem at a real moment sometime in the past. And once PostgreSQL introduces something, some methods, anything, it stays there once it ships, and PostgreSQL maintains backward compatibility. Okay. Well, authentication makes sense. That is, historically, you need to authenticate who is connecting to your database. And PostgreSQL evolved with in time to address the needs of the new era, and it just kept it. It just built on top of it. It did not replace it. Let's walk through those. In the PostgreSQL original world in 1990s, maybe towards the end of 1990s, world was a little bit different. PostgreSQL grew upon shared Unix machines on research and university environments. threat model was basically nothing. If you can already access the Unix box, you are a colleague. You are not an attacker. You are a trusted person. This assumption shaped the first generation of authentication methods. And you can still see that now. There are like a few ones. Like obvious one is trust. Like when you are in the when you are in the operating system, you are trusted by default. So Unix trusts why shouldn't PostgreSQL? And then ident was a little bit different. There was an additional process in the data server that authenticates you. But it is not as modern in today's criteria. The next one is peer authentication. That is the refinement over the ident authentication. That is basically operating system user. It just like this PostgreSQL knows the username and recognizes the username from the operating system. The goal here was just a convenience. Like PostgreSQL wants to let you in, and it doesn't try to keep you out. Let's go to a little diagram. So here is like Alice, the regular cryptography user. So user logs into the Unix user account with their own name or credentials and try to connect to PostgreSQL with trust or peer. And PostgreSQL knows the identity of user, but by the operating system username. There is no additional authentication is needed. Well, time has progressed, like towards the end of 1990s and maybe early 2000s, is that with the not invention but expansion of the internet, people are no longer connecting from the same box, but connecting to database from across other networks, across the world, or from shared resources, shared networks. Previously, like trust and peer authentication methods no longer addressed the need, and we needed passwords. Well, passwords just answer to the any services back then. Like when you want to authenticate something, you will just ask a password. Since like the world was already using the passwords, of PostgreSQL also introduced that, but there is some caveat that you don't want to store the plaintext password. Instead, you need to some sort of store something derived out of the password. And these are the hash. Like the MD5 was the original hash with some salt and everything. Like PostgreSQL stored the secret inside. And by the time progressed, like there were some vulnerabilities discovered in MD5, and another hashing method was introduced. Also, it came with a little change in authentication. With PostgreSQL 14, that scrum shell authentication was default, and it was basically challenge and response authentication. This way, you don't send a plain text password over the wire, so that it will give you a little bit of protection against like wiretapping efforts. So again, the same diagram. A client right now sends a password or MD5 hash or some scrum shell SHA challenge response data, and PostgreSQL just authenticates you. Here, maybe I should tell something about a little bit about authentication and authorization. Right now, I'm talking about authentication. That is Postgres validating if the user is really what they claim to be. Authorization is something else. Authorization is after authenticating the identity of the connecting person or entity, deciding whether that entity is allowed to log in. That is authorization. That is not the topic of this discussion. We are focusing on authentication only. Let's go next. Passwords look like easy, but they were actually hard because when you create a password, you need to store that in a long time. Rotating them are like difficult. So you need to rotate the password in the database and all applications or clients using them. Also, leaks was the problems because when you have a password, it is usually stored somewhere else. Actually, many places. There were stories of people writing their passwords in front of the on stickers on the monitors, so that eventually led to password leaks. Scrum helped a little, but it didn't change it because you are still storing a secret in multiple places, and that is prone to leak. So some new solutions were needed. Well, coincidentally, that is coincided PostgreSQL growing popularity, and enterprises took interest. But there are some gotchas there. Enterprises already know how to tell who are you. There were like identity directories, there were domains, auditings. Database was not a truth for identity anymore, and it shouldn't try to be. So external entities can and should provide authenticate users, and PostgreSQL just rely on them. Let's go for it. Well, the first one was LDAP. That is, PostgreSQL doesn't care about the password. It just asks LDAP to validate the password and authenticate. The other one is Kerberos or GSS API based things. So these are a little bit different. I will show that in the next picture. It is like your client first connects to that identity provider, and that provides you some token, something, yes, or some information, and tells that to Postgres. PostgreSQL trusts the decision made by the authentication, and doesn't try to do any further authentication, just trusts it. This worked for a while, and meanwhile, some other people thought about, okay, we don't want to store any secrets, but we can still authenticate. Certificates came in that picture. So it's like both client and server had their own certificates, own secrets, and the secrets are their own. There is nothing shared between them. So it looked like this. So you see that double arrows. So client had its own certificates, the server had its own certificate, and they tried to authenticate each other. So this seemed to be working fine for a while, because like client was proving its identity, and PostgreSQL is telling an identity, and there is a certificate authority that both parties trust, and that party helps you identify if that certificate is valid, and therefore authenticate your identity. Well, they were also hard. Well, hard part are not how the certificates were created, or how not the cryptographic part, but just as a passwords distribution part was hard. When you create a certificate, you need to be able to distribute that on all needed clients in a secure way. Your clients should be able to safely store them, and when the time comes, that certificate should expire, and it need to be able to revoked when something goes bad, and almost all problems with the certificates are operational ones. Cryptography are not involved there. Then something as well, just progression. Cloud was better, and the workloads changed a little bit. So instead of this long-lived connections, suddenly services were issuing very short-lived connections, maybe in the order of seconds. Maybe long-lived connection is now 30 seconds at best. And classic ways of authentication, like password certificates that are supposed to live long, seemed no longer necessary. They just didn't fit in. Like automations were there. There are no humans involved, so there's no need. There's no need to store password anymore. And some smart people thought about, okay, why shall we introduce this shorter-lived secrets, that is tokens. This is where actually things get more interesting. For years, like over every managed cloud provider, like AWS, Azure, Google Cloud, they have their own token providers, and they needed some specific extensions on PostgreSQL side to authenticate the token. And finally, in PostgreSQL 18, it said, okay, let's help you a little bit and introduce this native authentication methods. But it is a little bit different. PostgreSQL shipped the protocol. It didn't tell you how to authenticate. So any database should be configured to match the proper identity provider. That is, all of this idea is to reduce to this secret stored in PGHP account, so that when something goes wrong, you don't need to spend time or had hardship revoking the identity. Tokens were best there because you can create a token valid for seconds, hours, maybe 24 hours. Even if it leaks somewhere, token will already expire by the time it could be exploited. So this is how token work. So again, client connects to identity provider, gets a token, uses that token to connect to the PostgreSQL, and PostgreSQL has a way of validating the token, and if it can validate, it can let you in. Let's go next. So how we can choose between them? So, well, there's no best method. Like it depends on what you want or what you need. So if you are just developers doing some prototyping or development, you can use peer authentication, even Trust. I use Trust for a very long time. When you have a small applications that you need to maybe deploy to fewer clients, using this Scrum shell authentication, password authentication, well, could be preferable because it is easy to configure, and you can barely make a mistake there. But as soon as if you are enterprise users, if you have many users trying to connect, and you want to control individual like persons, you need to use LDAP or Kerberos-based authentication. Or you might be using a service like cloud service or some other service, and in that case, you need to be using either certificate that you can easily rotate, or maybe token like Enter ID, or out, whatever environment you are in. They're all good. but don't get into this mistake. Trust, that is very powerful. Don't ever use that in production. And you'll be surprised to see many people are still using it. The other are still like, they look different, but there's a common theme between them. It is when somebody picked a pretty strong authentication mechanism and skipped operational part. So like you can share passwords across services, you shouldn't. You can introduce certificates, but you don't have a sound rotation plan or sound revocation plan. Or like you did like LDAP authentication, but you didn't plan for how to revoke it. That is common mistakes. Don't fall in that trap, please. And PostgreSQL got something right. That is, there are many things, but if you ask me to choose one, I would say backward compatibility. So when a new version of PostgreSQL introduced, it never breaks you. Like you can safely upgrade your database servers, and your existing authentication methods will continue to work. And the flexibility, you can use multiple authentication methods on the same database, and operator has like very granular control. You can do anything you can do. And when you get into PGHP conf file, you will see the history. Like it doesn't delete all the authentication methods; it just extends it. So your takeaway from like this talk should be is that authentication is a history of trade-offs. So you need to make a decision at each go. And before asking how question, you need to understand the why part of it, why you want to do a certain authentication, or why you want to use certain authentication method. And if you have multiple options, prefer short-lived identities, short-lived authentication methods, and always optimize for revocation. Okay, somebody may be authenticated now, but it might not be in tomorrow or in a week. Just plan for that. In closing remarks, if your PGHP conf file feels messy, because the real systems are messy, it can get complicated too quickly. So just accept that and use it in a safe way. Thank you for listening. And you can ask your questions in the Discord channels. I will be able to answer anything you may ask. Thank you for listening again. These are the references.
Well, thanks very
Great
much,
talk.
Murat. Yeah, it's a long history. I mean, it's quite an old project, of course, Postgres, and it's kind of amazing now that we used to send clear text not just Postgres, but all kinds of software used to send clear text passwords in an unencrypted channel across networks. And each of these sort of steps, when you look back, it just seems crazy that we did that. But yeah, it's
that's a very interesting point you have, right? Because a lot of the architecture of the system comes from the 80s, where we were all using like time-shared systems, and there was no expectation that we need to protect from even the other users on the same system. So I do like look into the future and think like how PostgreSQL will have to change in some areas, like isolation between users, databases, and things like that in the future.
Yep.
Okay, but again, socks proxy to the survey, get your socks. That's the main point. And maybe let's jump into the trailer for the live stream 3, which is, I believe, in the US time zones, right? Later.
Yeah, I think it starts shortly after this one finishes. Well, a few hours. Yeah.
Let's roll. Okay, we have a brief technical hiccup, which happens. Okay, as we wait. Okay, let's wait a bit more for the trailer to run. Okay, in that case, let's get back to the surveys, because it's actually super important for everybody to do the surveys. It's important not for us as the hosts running the show, etc. It's important for your friends from the community that come in and actually do the talks. That's the best way to learn what you did wrong, what you did good, how to improve, and actually see, because, you know, we are not in a room. We don't know how many people see our talks. So seeing that, like, a person watched this, enjoyed this, or didn't enjoy it is like actually very motivating and important for people.
Especially if you did enjoy it. Yeah. It's good to get feedback.
True. Okay. I guess we have a technical issue with running the show for a moment. I'm going to jump a few slides back into the hallway track slide. Most of the conversation is happening on Discord. If you haven't already, please join. Most of the speakers are there. We have been having conversations all day, ranging from like the beverage of choice, whether it's coffee or yerba mate, or to horror stories from migrating various databases, up to most recently authentication and other interesting topics. But I'm going to, like, since we were waiting either way. Oh, okay. I guess we are ready. I was about to change topics. Well, we'll have to catch you after the show then, Thomas, for my questions. Okay. So can we please run the trailer for Livestream 3?
Hi, I'm Bruce Momjen. Today I'll be delivering a talk called The Wonderful World of WAL. The write-ahead log is a fundamental part of Postgres. It allows implementation of crash recovery, physical replication, and logical replication. People who are curious how these features work and how to make best use of them will find this talk entertaining and useful.
Hello everyone, my name is Dia Radwan. I'm part of the global Black Belt team in Microsoft, covering EMEA, focusing on Postgres and other open source databases. This session is building event-driven systems with Postgres, logical replication, and RASI. In this session, I'll show you 3 ways to tap into that stream and build event-driven architectures directly on Postgres. We will run live benchmarks, compare real latency numbers, and look at working code that you can deploy today.
Hello there, my name is Paolo Golub, and I'm a senior developer / consultant at Cybertech. And today I want to introduce you my new tool, pgcov, which helps DBAs, developers, DevOps, managers to measure the coverage of SQL and PGSQL code to know which parts of your code are actually executed during the tests.
Hi, my name is Jeremy. I am a Postgres engineer at Geico.
Hi, my name is Leo. I am a native PG maintainer.
We're going to be talking about an exciting feature in cloud-native Postgres called failover quorum.
And you definitely need to know it if you use synchronous replication.
Hey everyone, my name is Abe, and today I'm going to be talking about one of the most important shifts in the way we work with databases today. The move from simple queries to AI agents. So if you're a builder or someone who just loves to make apps on the side, you can stay for this talk.
Hi everyone, I'm Divya Bhargav from Postgres team at Microsoft.
Today we are going to be diving into the real-world performance gains of Postgres 18 over 17 using actual production query patterns. No synthetic benchmarks here, just SQL you'd really run. Let's explore not only how much faster it is, but why it's faster and what that means for your workloads.
Hi everyone, I'm Julia. Hi, I'm Paola. And together we are responsible for the development of Serenity Star. We are also active users of Azure database for PostgreSQL. We've been using it for the past couple of years as part of the infrastructure setup of our platform, and we want to share with you some of the lessons that we've learned along the way.
Today we'll walk you through how we implemented retrieval augmented generation in Serenity Star, including some of the architectural decisions behind it. We will talk about the challenges we face and how we solve them using Azure for database for PostgreSQL.
Hi, my name is Varun Dhawan. I'm a principal PM with Azure Database for Postgres team at Microsoft. Today, I'm going to talk about the massive shift which is happening in the data architecture pattern and the rise of Postgres as the everything database. So please join me.
Hi everyone, I'm Sai Srirampur and I'm here to talk about Postgres isn't slow, your storage is. In this talk, we'll double click on what are the common problems that Postgres users run into. We'll see that most of these common problems tie back to disk and IO performance. We'll also present the secret sauce that solves most of these problems, which is local NVMe storage. We'll do a bunch of benchmarks which show local NVMe performance over EBS-backed storage. And as an icing on the cake, we'll talk about how do we take this to production? How do we get an enterprise-grade Postgres with local NVMe? Great to be here again.
Hello, everyone. My name's Ding Ding Lu. I am a product manager at Microsoft. Welcome to Posette 2026. Today, I'm going to bring you a talk called Why We Built Azure Horizon DB. If you are a developer or a DBA and wondering what additional benefit Azure Horizon DB may bring to you, this is the talk you want to join.
Hello, my name is Sarath Baladiapalli. My talk is about maintaining large tables in PostgreSQL. I'll be discussing about various performance challenges associated with maintaining large tables in Postgres database, along with recommendations or solutions to have a consistent performance. The talk basically targets database developers and database administrators.
Again, a great lineup. Can't wait to see that. Okay. Go ahead.
Yeah, I think so. Next, we're going to hear from Gülçin Yıldırım, who's going to be talking about the new constraint stuff, which I think means the temporal stuff that came into 18 and is still being developed. That's a really exciting area. So yeah, really happy
Looking forward to it.
Yeah, let's roll.
Hi, this is Gülçin Yıldırım Jelínek. I do product at Zeta. Today we will talk about what's new in Postgres 18 with constraints. I read all the changelog, so you don't need to go through it yourself. And the talk is for everyone who is interested in constraints and app development with Postgres and into also database internals. I hope you will enjoy it. Okay, let's dive in. What's new with constraints in Postgres 18? Today's agenda looks like this. We will mainly focus on temporal keys that is introduced recently. We will talk about how not null became a first-class constraint. It's kind of promoted from being a flag in PG attribute to a full force constraint. We will talk about the new concept not enforced. We always had for a long time we had the not valid concept already, but not enforced is new. We will talk about that too. And there are some improvements to partition tables with the constraints, so we'll go through that as well. Okay, so let's start with the basic question, basically, like what is a constraint? When you define a table or a column, you can attach rules to them to check or enforce something. So this is important for keeping the data integrity in check and to avoid subtle data-related bugs later on. So these rules are all called constraints, and data types itself also restrict the kind of data a column can hold, but they are usually too general, too loose. So to be able to, let's say, You can't make a numeric data type to only exact positives, right? Or you can just ensure unique product keys or something like that with just normal data types. You have to have unique constraints. So this is why we have the constraints, and it is important to understand them early on when you are modeling the data, so that later on you don't need to go through the cleaning this data later on. You don't need to deal with it later on to prevent the bugs. So it is important to keep your data valid and consistent. Okay, so there is another way we can actually look how the constraints look like. They all have a matching entry in PG constraint catalog. So as you can see here in the table, constraint type is reflected with their name. So check and C, foreign key F, not null N, and so on. And before Postgres 18, you wouldn't see not null here. This is a new edition. So yeah, you can see them all here. So any constraint that you created, you can check them through the PG constraint catalog. And if you are new in Postgres, if you don't know what catalog is, it is a system table. So Postgres keeps data about your own data internally. So let's say you have products, orders, users, those kind of tables. And Postgres keeps information about those tables, like how many columns there are, what type of indexes it has, what are the types of these columns, and so on. Specifically for constraints, we keep all this information related to constraints in PG constraint, but there are more of those, like PG class for the table, PG index for something related to more specific indexes, although most of them are actually in the PG class, PG type for the types, and so on. So there are a lot of catalogs, and this is kind of Postgres' internal metadata. Okay. So this was just like basic intro, and today's focal point is like what actually changed in Postgres 18. And I made a list that you shouldn't read now. We will go through all of it, and we will start with the top one about temporal keys, the newly introduced temporal keys to Postgres. And another thing that I wanted to actually show with this slide is how much work goes into Postgres in each release. These are all patches, and some of them are, for example, not null is being developed, discussed since 2010, and basically now it is in Postgres 18. It took so many years, like 15 years, and it was actually going to Postgres 17. This happens a lot, right? A patch can go to targeted to went into a release, but it can't go as expected. There will be maybe some issues, some more tests required, and all of those. So I just wanted to show here how much effort goes into each release, and I wanted to thank everybody who developed this, who reviewed these patches, who tested it, who documented it, and all of it. Okay, so before, as I said, let's go. And before we start exactly what is a temporal key, I wanted to step back and see what makes a database actually temporal. So what I colored in purple in the middle with the fourth and fifth criterion, these are what is just introduced, the temporal primary keys, unique keys, and the referential integrity we refer to basically the temporal foreign keys. And we will talk mainly about those. But you can see there are most of the stuff already green marked, because I marked what we have, and we partially have the support, or we kind of support all of it as green. What makes me very surprised that whenever I need or whenever I learn a new database concept, I came to Postgres and we either fully support everything, we have built-in support for those, or we have parts of it, building blocks of it to actually make this work. So this is the almost same scenario for the temporals too. Of course, the new additions, like the new temporal keys, closing the gap super quickly. But we already have some of the stuff, we have the range types, the first criterion. We had operators, range operators that you can actually do the temporal queries. And what we lack is mainly the first red marking in the third criterion is the system maintained transaction time. And we will talk about it, what's valid time, what's transaction time later. But yeah, we pretty much cover all of it. And this is amazing. I mean, I'm always surprised, and I want to share this with you too. So as I said, the time is different for temporal databases, because normally for relational model, time is just time. But for temporal databases, it is a first class part of the data model. So there we have the ID in a way attached to always with a period. So that's what it makes it like a dimension, and it's always there. So valid time and transaction time, there are two semantics here. The first time refers to, for example, I put an example here to make it easier to understand. What do I mean by like when it is considered true in reality? So the fact it will be true for the business domain. That is what how they actually explain it. Imagine there's an employee salary table. An employee's salary was like 5,000 from January to June 1st. And June 1st, the salary became 6,000. And there is like no upper bound limit there. So it's unbounded. And that is what we can see now. So this is the valid time. When we look at it, we can actually see for this employee in which period this information was correct. For example, if I'm querying for the March, I know that the salary was 5,000. So I keep this change with this value and when this happened. And what do I refer as transaction time, the system time that we lack of? And usually in the SQL standard, I think it's like system as of system time clause, which we don't support yet. So this is only if we had this already, we would know when this change happened. So imagine the case that an HR employee changed the salary on June 10, but this is effective from June 1st. So for us, then the transaction time when actual database knew this information would be June 10. So this is transaction time in the simpler terms. And usually in the relational model, we don't really have this like, when you update the salary, right? You lose all this information. Then you can't just say, what was the salary in March? When did it change? And was there any overlap or gap? That type of thing. But when you actually build it in the model, like the valid time model, then you actually can do like, okay, what's happening? You can query the overlaps. You can actually stop the overlapping because then you could actually put the temporal keys that will allow you to do so. And that will be what we will talk later. And yeah, so I think this is like important because it's a different way of thinking, different way of modeling. And I'm happy that now we can actually do this in Postgres too. Okay, so this is something before I show you the exactly queries, how they look like, what I learned from Boris Novikov when he visited Prague in June 2025, a year ago. He said, and I quote it here, queries to a temporal database return facts that were, are, or will be actual at a time that may differ from current time. So this is a concept actually really defines what we talk, like each data row has an associated time period. This is how you define it. Periods are closed open, so they never overlap. And that's why we are doing this, non-overlapping clause. And for a period, for the foreign key, that's where all it comes from. So the relational model and the temporal model is in that way differs for how they approach to time. When you have fully temporal model and you implement it, you can actually do proper point in time queries, and you can just do history of an item like event logs type of information, and you can just feed this output of one temporal query to another temporal query and so on. And also like how modifying the data is also different. Like we normally, if you want to delete something, we delete it. And then here in the temporal model, what they do is like they only close the validity periods basically. And then it means that it's kind of deleted. So it is really nice. It is nice to think, as an exercise, it's nice to imagine how it will be done, because now it's much, much easier, more native. Before this could be done like differently with exclusion constraints, with gist indexes, which I will also show. But now it's much easier. You can just use like primary key, foreign key, DDL syntax, and it's amazing. And here I also wanted to show now, like, what do I mean? As you can see, like if I want to now query, as I said, like what was valid on March 15, this is the thing that I can just say, okay, give me like, I want to see for what happened in March 15. And then I can also now enforce this rule. Yes, an employee cannot have two salaries valid at the same time. And for that, I just created a primary key. And what's important is like the syntax without overlaps only comes to the last column. And this needs to be in a range type or multi-range type, the valid period here. And the scalar key here is the employee ID. So together with this employee ID and valid period, they become, the entity. This is where we keep the primary key in a sense, like together, employee ID and this valid period. They are like together, and then we just see the salary value changing over time thanks to this kind of setup. Okay, yeah. And then again, let's see how the exact syntax looks like, just as a reminder. As I said, we need to use gist indexes here because gist already has this concept. Like it was making sure the underlying mechanism works for non-overlapping. And you instead of you just create the extension, gist extension, and then you can just do the temporal primary keys. Here I wanted to give another example to make things a bit more stick. Imagine an availability bookings system, and I want to make sure that one booking can only be done for one room for only one period. That's why I do just like room ID here and the create table bookings and during without overlaps, because I don't want this to be overlapping. I can't just overbook a room. And then let's try to insert. And so for the rooms, I insert 2 rooms, like blue room and green room. And for the blue room, the first room, I want to insert like from, let's say, 2 values, from 10 to 11 in the same day, and from 11 to 12 the same day again. And now if I try to insert like from 10:30 to 10:45, which will collide with the first period, I can't do that. So I see this purple output here. It's complaining that, hey, you can't do this. And now you could see how easy it was, right? What we do, it was just like adding this during without overlaps. And that's it. We did it. And this is also valid for the unique constraints, the same kind of syntax. Instead of primary key, you just do unique there, and that will work the same way for the uniqueness. Okay, and then if I want to, of course, insert an information for the room that doesn't have any booking, of course, it will allow it. And I can see that it worked. The first query, I inserted for the 102, the other room. And then since it is a new implementation, it currently doesn't accept empty values. So I wanted to show that with the second query. I tried to insert an empty range, and that didn't work. Okay, just to summarize now for the temporal primary key and the unique constraints, the clause is without overlaps. It could be for primary key and unique constraints. And if you remember what makes a temporal database chart, there was like uniqueness and primary key and referential integrity with foreign keys were required. So this all 3 needs to be working together to be able to check all those criteria. And as we said, instead of B3 indexes, we use gist indexes here, and you have to create the extension. And if we didn't have this before, how people were doing this, working around with gist, exclude using gist. This is how we were doing, creating a constraint. And as you can see, like room ID width, so this is the scalar key, that is the same business key, and the ranges overlap. When you exclude it, it's kind of not overlapping, right? So they were like doing it this way before. Okay, and I want to show also to complete this part, how it would look like for foreign keys, because normally, right, when we have a standard foreign key, what we know is that for every referencing row, there exists a reference row with the same key. So it's kind of equality based on the principle of an equality notion. So there's matching. But for the temporal, it's complicated, right? It's not like this easy. So for temporal data model, it's like rows are valid for like over some time period, right? And so referential integrity also must hold during this period. So it is not a match for a single point. So it's periods containing periods. So that's why it's kind of a way of thinking differently. So here, what I wrote here, like constraint bookings, FK availability is like, imagine if you had, let's say, bookings table again and room availability, and a booking is only valid for, let's say, some time range, and a room is only available during this range. You need to make sure these are referencing to each other. So because if a booking depends on the room availability, you want to keep this relationship intact. That's why you need to have the bookings period during, it needs to be referencing, available period. That's what I added. So it's kind of different because in the primary key, we were adding without overlaps clause after the column. And here you are adding period during. So it's the order is different. But yeah, it's super simple syntax when you think about it. If you were doing this the other way around previously, it would be much more complicated than this is. Of course, there are like some limitations, like there are some on, update, delete, cascade, those kind of functions are not now supported yet, but I'm sure eventually it will be made. It's kind of harder, right? Everything is much more harder than relational model here. Okay, and yeah, with this we finished the temporal topic for now. And as I said, like for Postgres, we had not valid supported for a very long time, but not enforced is something very new. So why we actually needed not valid even in the first end? Because when if you can add a constraint as not valid, this skips the initial validation, but enforces the rule that we add going forward. And now Postgres 18 takes this further. Now you can declare a check, and foreign keys we will talk more later, as not enforced. So it will be never checked, but it will be still documented in the schema. So it is started with the check constraints. As you can see, you can just create the check constraint now and just add the not enforced clause at the end, and that will never be checked now. And PG constraint catalog got a new column, constraint enforced. It will show the status of it, so you can actually switch between enforced and not enforced. But you can't do this for check constraints now during the alter operation, so you have to drop and recreate the constraint. But I think the second slide, like the why we have not enforced, I think it will be more useful, because for the foreign keys, when a foreign key is created, then there are some triggers also created, right? And so if you create something now with a non-enforced, that changes things. Since we are not checking or enforcing anything, then you don't need to create these triggers, right? You don't need to create these triggers. These checks are no longer required. And the constraint itself will be marked as not valid. And you can change this, right? So if you want to change some not enforced constraint to finally enforce, then this missing triggers will be created and the constraint will be changed to valid. So you need to know when you actually enforce something, there will be a validation scan that we were trying to avoid at first. So this is good for planning rollouts, so that you know when you can actually run these things, validations. But you need to be aware basically from the behavior, how it looks like. And also you can just take an enforced constraint and make it not enforced. That way, again, we are going back to the state of not enforced. That means that triggers will be dropped. And again, the constraints will be marked as not valid. But this is super because it gives you, lots of flexibility about how you want to plan this thing. And I think it's more important for foreign keys than the check constraints. Okay, there's another kind of relatively small change, I would say, comparing to this, temporary keys or not null and not enforced. The correlation issue. So for Postgres, string comparisons, of course, depend on correlations, and non-deterministic correlations are kind of expected to create surprising results sometimes. So to prevent this going further, Postgres now requires either both primary and foreign key relationships use the deterministic correlations in both sides, or if they are using non-deterministic correlations, they need to use the same non-deterministic correlation on both sides. Why this is important? This might actually break when you do PG dump or PG upgrade, so you might need to do the schema changes first before you go and upgrade, or do the PG dump and restore. Okay, and now we will come for the next group of changes. As I said, another big group of changes are not adding addition of not null constraints to PG constraint catalog. And now we have as you said in the table earlier, the con type n, And now you can just list them in a table. So if you do \d+, you could see all the constraints, and it will include a section for the not null. It's a bit like noisy now, but maybe it could be optimized later on. And once you have a constraint instead of a flag, what you could do is like there are a lot of opportunities that is open now for not nulls as well. So you can name stuff, right? That's easy. Or you can drop the constraint, like just, normal drop constraint. You can alter it. You can change the inheritance. Yeah, there's a lot you can do with it. And we will see some of the stuff in the examples as well here. Again, so once you have a proper constraint, it brings you to not valid. And we all understand, right? We are trying to avoid getting locks. We are trying to avoid getting, when you add a constraint with not null, you were getting, blocking writes. So if you don't want to block writes, how we were doing before this change, that we were adding a check constraint that does the not nullness flag. And then we were validating later on because every scan is different. So we were trying to lower the lock strength, let's say. And then we were setting not null after we actually worked through this. And now we don't need to do this. We can just say alter table at constraint, edit as a not null as not valid. And that's already really good. I think that's the most important thing you can do so that you have less impact on your system while you are creating the constraints. And yeah, so you can actually see this behavior with a new con-validated column. It is stored here, sorry. And the rest is pretty much the same. You don't need to worry about dumping and restoring. It behaves similarly. And inheritance, of course, once you have, again, a proper constraint style, you can actually allow the not null constraints inheritability. So you can just say alter table alt constraint, set inherit or set no inherit. And if you want to have something like no inherit to inherit, this is simple. It just adds the missing PG constraint entry for the children or the tables that are inheriting. But you can also do the other way around. If there's an inheritance, if you want to do the no inherit, you can do that too. In this case, what will happen, the connection between parent and child will be cut off, and the constraint in the child will not be touched. It will be only dropped from the parent, and the child tables will continue having this constraint as almost a local constraint. And yeah, basically from then on, from the parent, this will be not propagated for the new children, and the children who has this constraint can keep this constraint if they like to. Okay, and now we have some improvements on the partition tables that I want to add. This is the last part of our presentation. Allowing not valid foreign keys on partition tables. So this feature was omitted when the foreign keys were implemented for partition tables, but this has been requested. So now it's clear why it's useful, because now when you create this foreign keys, if you allow it as not valid on partition tables, you can actually do each partition validation independently. Of course, it will reduce the scope to that partition instead of blocking writes in everywhere, for example. So it needs to be able to avoid the locking for a whole table. Now you can just choose and do one by one validation. But if you want, of course, you can also still have the same behavior. You can run once on the parent table, and that will validate all the child foreign keys in one go. And of course, once you have the basically not valid, and you can also do the not enforced. Yeah, and that is also another thing, very small thing. We can drop only on partition tables. This was actually restricted because add only is not possible on a partition table. You can't have a constraint that's only for the parent. You need to have it for the children too. But symmetrically, this was taught kind of wrongly. Now you can actually do drop only on partition tables. And there are, of course, more changes coming to Postgres 19. If you want, you can check it. I'm putting here just for a reference later on when you see the presentation. I don't know if they will go into the Postgres 19 and what is the state, but yeah, the developments are still going on. And yeah, we reached the end of the presentation. Thank you for listening to me, and I hope you enjoyed the presentation, and let me know if you have any feedback and recommendations. I'll be around. Thanks.
Great talk.
Yeah.
It's always nice when somebody does, deep dive and gets you through like all the functionality.
Yeah, I think that temporal stuff is fascinating. I've seen things like that done without database support, just with a lot of pain and very complicated queries.
Yeah.
It's really exciting to see that, this. It's driven by the standard, and yeah, but Postgres' take on it. So good stuff, and thank you very much.
Yeah. And again, leave survey feedback, get your socks, wear your socks to the next PostgreSQL conference. And next up, we have Alexander Kukushkin, who is also a colleague here with us at Microsoft. Alexander will talk about PostgreSQL queues done right with PGQ. Let's roll.
Hi, I'm Alexander Kukushkin, Principal Engineer at Microsoft. Today I'll talk about PGQ, Postgres extension implementing queues that has been around for almost 20 years. I'll explain why it outperforms skip lock-based design and how to use PGQ on cloud-based Postgres. Let's dive in to PostgreSQL queues done right with PGQ. And agenda for today's talk. Why one want to run queue in the database? Why not to use external queue? Then, like how people naturally approach implementing in database queues using select for update skip locked. What are the problems and disadvantages of this approach, and how PGQ solved this approach solved these problems many years ago. Basically, I would like to reintroduce you a PGQ extension. And finally, we are going to discuss how to run PGQ on managed cloud services, which don't support natively this extension. All right, so why engineers want to run queues inside the database? Why not to use something external like Kafka, RabbitMQ, or you name it? There are many different technologies that allows you to running queues outside. First of all, because it's totally new technologies, they have their own learning curve, sometimes very steep, and you of course need to run separate hardware like to support external queues, and so on and so forth. Unfortunately, it's not very easy to have consistency between the database and external queue. However, when you have a queue inside the database, you can insert events into the queue in the same transaction and be fully consistent and atomic. After all, database is a single source of truth for your application. Naturally, people tend to implement something very simple, like presented on this slide. They create a very small table, very simple table with just 3 to 5 columns. One of them is a primary key, which is used to refer like to unique events in the queue, like timestamp field and the message which contains the event. Inserting into such queue is simple insert statements. You just insert messages from one connection or from multiple connections. Like sounds very simple. Consuming from such a queue a bit more complex. Very first thing that people usually do, they start a transaction and use a select for update ordered by identifier primary key with some limit, and they use skip for update skip locked. Why they want to use for update skip locked? Because the people want to consume events from multiple connections, from multiple applications, and this way they split jobs between them naturally. Like once they selected a certain number of events, they process them, and for successfully processed events, they remove them from the table by using primary key, the ID column. And at the end of transaction, they commit. If some events are not processed, then they will be available for the next time. However, there are certain problems and disadvantages. Of course, such approach has advantages too. First of all, it's extremely simple and easy to implement. You get parallel consumption of events out of the box, but disadvantages are much bigger. Like you keep transaction in progress while processing events. It means that while you're processing events, you accumulating more and more the tuples on the table. Then, like by doing select for update and by removing rows, you also introduce the tuples, and it requires some aggressive vacuuming of the queue table. In the situation when you have a spike of events that being inserted into the queue table and slow consumers, you have quite fast growth of the queue table. And while you are processing events, like with not enough speed, you accumulate more and more tuples in the table, live tuples and dead tuples as well. So at the end, you get some loop of problems. Like the bigger queue table becomes, then the slower consumers will work, and so on and so forth. And problems also will be amplified by some other long-running transactions in the system. For example, if someone is doing sort of OLAP queries, it will also prevent vacuum from doing its job. So people try to fight this problem. And what they usually do, they extend queue table by a few more columns. One of them is a column with the name VT on this slide. So VT stands for visibility timeout. It says when events should be processed, like at what time. And they also want to limit number of retries to process the event. And it is being solved by introducing yet another column, read count. And as you see, we introduced also a new index on VT column, because sometimes for Postgres it's much faster to select events from this table by using the index on visibility timeout column. And our select, previously very small and simple, becomes CTE. Now we have to do additional filtering on visibility timeout. And after selecting some number of rows, we update them by setting visibility timeout somewhere in the future. This is the time when event is supposed to be retried next time if it wasn't processed successfully. And we also increment read count. So once we selected some number of events, we process them, and after successfully processing, we remove them from the queue table. Seems to be a bit better, because now we don't have to keep transaction in progress while processing events, but at the same time, we started doing yet another update on the table. So originally we just inserted event into the table, then we did at least three updates, like select for update, actually update the row, update, also update the row, and insert the new one, and delete, also update the row. That's quite a bit of overhead in terms of writes. We also introduced a new index on visibility timeout column, which effectively disables hot updates optimization. And Postgres will not be able to optimize for hot updates, and you will get not so good space utilization. And index on visibility timeout may also confuse planner, because planner may at some moment think that it's more beneficial or faster to use column, so visibility timeout index, rather than primary key. And queries that were taking just a few milliseconds, queries on the queue table, may start taking 10 seconds, like 20 seconds, and so on, which is just a few orders of magnitude slower than it's supposed to work. How can it be improved? So in order to fight with bloat on the queue table, it's recommended to partition it or just create some more than one table and switch between them when writing and consuming events. When events are fully processed from one partition, it could be just truncated or dropped, and because like new partitions will be used. This way, we eliminate the need to fight with the bloat and use something like pgrepack or reindex concurrently, or pgsqueeze, or something, or repack concurrently, which will come into new Postgres 19. Ideally, we should avoid doing so many updates and deletes on the queue table. But how we can actually remember which rows were processed? It's quite simple. We can keep a pointer to last identifier which has been processed. And when we selecting from the queue table next time, we just in the select request rows with identifiers which are bigger than the last processed ones. When processed the next bunch of events, we just update last identifier in some other table. Like we just keep pointer, and in this case we need to think something about retrying events, and it could be solved by reinserting them into the queue table. So, or instead of reinventing the wheel, we can just use PGQ extension, which does it natively since the very beginning. PGQ is quite old extension. It exists since 2007 publicly. It was part of SkyTools back then. If you are not familiar with SkyTools, it also contained PL proxy that implements sharding, and PG bouncer tool that implements connection pooling. And like, it's quite surprising that many people know PG bouncer but never heard of PGQ. Packages for PGQ are available on PGDG, like for Debian-like systems or Red Hat-like systems, like dep and RPM packages. PGQ implements event handling based on snapshots, which is fully transactional, and it employs batch processing optimization. Interface of PGQ is like fully SQL. It provides a few functions to insert queues, to process them, and so on. PGQ supports multiple producers per queue and multiple consumers per queue, but consumer will see all events that are coming in the queue. How can it be installed? You just use your package manager, like in your Linux operating system, and you need to install PGQ3 package, and on top of that, unfortunately, you need PGQD package. Without PGQD, PGQ will not do anything. PGQD, it's a maintenance daemon that responsible for like some tasks that happens under the hood. All right, so once packages are installed, you just need to create extension. And once extension is created, you can use very simple SQL API to work with queues. You need to use create queue to define a queue, and you can symmetrically drop the queue by using drop queue function. In order to consume events, you have to register consumer, and consumer will see events on which were added to the queue only after it was registered. To insert events, you simply use insert event function. It just adds event to a queue table. But to consume events, you need to form a batch which is done by using next batch function. This function returns batch identifier, which later should be used in get batch events function to actually fetch events from the batch, and finish batch function will close the batch and discard like processed events. So let's zoom in and look into what's inside PGQ extension. There are a few configuration tables. We will take a look closer at these configuration tables a bit later, but the event one table, it's a table which was created by createQ function. So in fact, we have not just a single table, but one parent table and 3 child tables. PGQ isn't using table partitioning. In fact, it's using table inheritance. And it's not because table partitioning did not exist almost 20 years ago, but because those tables are just used independently of each other. And PGQ inserts and selects directly from every child table independently. So in the PGQ table, we have a Q name, which reference a Q table, and it also defines that we have 3 child table for a given Q. And every 2 hours, like showed here on the slide, Postgres will, so PGQ will switch to a next event table. Like while doing inserts. Okay, so and if we look closer at one child table, you will notice that it has just a single index on transaction ID column, and you will also notice that it disables after vacuum. So why one should disable after vacuum for the table? It's very simple, because we don't expect any updates or deletes on this table. Therefore, it does not need to be vacuumed. And more important, like after 2 hours or like after max 4 hours, this table will be truncated. Therefore, we don't want to don't want to waste IO operations by doing unnecessary maintenance on this Q table. Okay, so now I would like to discuss a little bit details about how batch processing works and like why do we need PGQD process. So main responsibility of PGQD process is to produce ticks. Ticks are inserted into PGQ tick table. It's on the right side of the slide, and every tick contains transaction snapshot, which was at the moment when tick was created. And batch is defined as all events that happened between 2 ticks. So on the left side of the slide, in the bottom, we see batch number 1, which is which includes all events between ticks 1 and 2. So, and when we read batch events, we just call get batch events function, and it returns events. But what happens under the hood of this function? Under the hood, it actually uses dynamic SQL and selects from a single event table. In fact, sometimes it may select from 2 more event tables, in case if it can understand that some ticks were stored, so some events are stored in a different child table. So in this case, the union all will be used. What's interesting here, we are not just searching for events between 2 transaction IDs, but also doing some filtering using TXID visible in snapshot function. So why is it important? Because it may happen that transaction ID like that falls into this specific range wasn't yet committed at the time when the next tick has happened. So that's so PGQ is using MVCC Postgres MVCC implementation to find events. All right. So and when we finish batch with PGQ, so we call finish batch function apparently, and the only thing it does, it just updates subscription by moving a pointer, like last tick pointer, which is on the right side of the slide. So it was before like pointing to 1, and now it points to 2. So next time when you will create a batch, it will start from tick 2. Okay, so how can we run PGQ on managed services? Because none of the most of managed cloud providers that offer Postgres don't support PGQ. Does it mean game is over and we cannot use it? No, it's totally not. So PGQ is mostly implemented in PLPG-SQL language, which is a trusted language. There are just 4 functions that are implemented in language C. Those functions exist only for performance reasons. However, starting from year 2016, so almost for 10 years already, there are alternatives available which are implemented using PLPG-SQL. And to use these functions instead of C functions, we just need to build PGQ using make PL only. So we clone PGQ from GitHub, we run make PL only, and it produces an SQL file which you execute inside your database. And when this file is executed, you get full list of functions that define PGQ extension. And you can use it the same way as it was, if PGQ was created using create extension. Okay, so if you remember, like PGQ requires a PGQ daemon where we can run it. Like if we want to use PGQ on managed services, we have a couple of options available. First of all, you can run PGQD on some virtual machine. Like it hasn't be very powerful. Something very cheap and small is enough because it's not running any heavy calculations. It just need connect to a Postgres and run PGQ maintenance function from time to time. Or the second option, you can hack your own solution on top of pgcron. Pgcron, it's also a Postgres extension that implements cron-like jobs directly in Postgres. And if you look at pgcron GitHub, you will find that it is supported by at least 15 cloud platforms. And only one cloud platform does not support PGQ out of this list. I'm not sure if there are people who still use this cloud platform nowadays. To understand how to re-implement PGQD using pgcron, we need to know what PGQ does under the hood. And it does just 3 main tasks. First, it produces ticks, basically inserts data into PGQ tick table. It happens every second by default. Then the second task of PGQD, it handles retries by moving events from PGQ retry queue tables to actual queue. And the third task that PGQD responsible for, it's a maintenance operation. It has to rotate actual child tables and from time to time truncate them based on the configuration. So retries are handled by PGQD every 30 seconds and maintenance handled every 120 seconds. The beauty of PGQD that it does not implement any sophisticated logic in itself. It relies on functions provided by PGQ extension to do the job. So in case of ticker, PGQD just calls a PGQ ticker function, which is already there. In case of retry and maintenance operations, it's a bit more sophisticated, but still under the hood, there are PGQ functions that it will call. But we need to provide some wrappers for these functions implemented in PL/PG/SQL SPL/PG/SQL procedures, not functions. Why procedures? Because we want to commit after every call of the function. So on this slide, you see PGQD retry function, which handles retries by calling PGQ main retry events function in a loop, and it breaks from the loop when the function starts returning 0. What means that all events has been moved from the retry table. And the maintenance function a bit more complex, but still it works in a way that main operation functions returns a set of names like function name and function arguments, which has to be used when calling a function. Basically, we get list of functions to be executed, execute them, and after every execution, we commit. So this is exactly what PGQD does under the hood. So be careful, don't turn after vacuum off, because PGQD also, like in PGQ, also sometimes may vacuum PGQ configuration tables. Why it was doing this? Because like 20 years ago, there was no after vacuum in Postgres yet, and therefore such task has to be offloaded to some external tools. And as a good citizen, PGQD was trying to do it to solve this problem. And the second issue, like pgcron itself, for every job that executes, it inserts status of execution into job run details table. So this table will grow very quickly because we run ticker every second. So it would be nice to have another cron job that cleans up cron job run details table. Okay, so coming to the end. So to recap, PGQ, it's a great queue for Postgres. It was designed and implemented by real engineers and real Postgres hackers. It does not use skip locked. It does not generate table bloat. There will be 0 dead tuples in the queue table and absolutely no write overhead. Some people claim that PGQ is old and unmaintained and maybe even deprecated. In fact, it is not. It is stable like rock, and most likely it is bug-free. If you look at GitHub, you will find that last commits to PGQ only update README files mentioning that it supports Postgres 17 and Postgres 18 without any changes in code. Unfortunately, documentation for PGQ extension isn't great, or I would say it is absent. You need to do a lot of research on the internet to make it work. However, PL/PG/SQL is a relatively simple language, and you can learn a lot by reading PGQ source code and understand how to use PGQ API. Of course, there are some libraries available on the internet that implement PGQ support for Java, Python, PHP, and so on. But since it's a SQL API only, you can implement easily PGQ some libraries for your own for your favorite language. That was it. Thank you for listening. I hope you enjoyed.
Great talk, Alexander. Every project evolves finally into implementing a queue of some sort.
Yeah. Yeah, I think I'm pretty sure we've all built, if anyone who's worked on database applications must have built many versions of at least naive queues. So yeah, very interesting software. Cool.
Yeah. Again, if you want to ask questions, I see that there are some questions and Alexander is actively answering them on the hallway track. So go ahead and join us there on Discord. And also be sure to leave survey feedback and grab a pair of socks to wear at the next conference outing. Would you like to introduce our next speaker, perhaps?
So Mohsin Ejaz is going to be talking about risk-free AI tuning for Postgres. Fast cars need fast breaks. I don't know what that means yet. I'm really looking forward to finding out.
Sounds exciting.
The title of this talk is Fast Car Need Fast Brakes. I guess that's the whole point in one sentence. In our industry, people, tend to go faster. They do want to do things faster, but nobody really talk about brakes. Nobody really talk about the safety mechanism that needs to be built around, getting it faster. And in this talk, I'm going to talk about how to build your safety mechanism when you're building your AI solution. Let's get started. Building safety tooling for risk-free AI tuning of Postgres. A little bit about myself. My name is Mohsin Ejaz. I've been in the industry for close to 2 decades now. I've been in DevOps, QA, and release management, mainly with Postgres. I've served most of my time with Enterprise DB. I specialize in CI/CD automation, database benchmarking, and QA and release management side of things. For the past 3 years, I've been serving as a senior DevOps engineer with dbTune, where I'm working as a benchmarking expert. I also serve with customer pre-sales activity, customer engagement. My main focus is reliability and performance with real world workloads. I regularly work with the customers on performance troubleshooting issues. Plus, I regularly give technical demos and and enabling. So that was like a little bit about myself. So yeah, let's talk about why we are here. So what's the promise? We have a lot of buzz related to AI, right? Everybody talks about AI. It's a next big thing. I will not say next big thing. It has been a big thing for quite some time now. But when you talk about AI-based tuning, what's the promise? The promise is it can explore, complex parameter space really very quickly, like in very short amount of time. So if a human takes days or maybe multiple hours, tuning, an automated AI solution can do it pretty very quickly. It can then in turn reduce your day-to-day activity of your specialist tuner, so he can do any other things. Plus, it learns from your early sessions. So it is not like one-time solution which you just build and when you run it again, it will again have your heuristics. It will not take off, thought about heuristics. It does learn from every session. So that's a promise, which is very appealing. And in this fast-paced world where things are moving very fast, everybody is very busy. They are with, people having multiple tools and multiple things. Productivity needs to be high. So this is a very, what you call an engaging tool. But this comes about, the fear part of things. What if AI picks a dangerous configuration? You're letting your AI touch your production system. It's like giving a log to your safe. And if you are passing a log to your important production system safe, you need to be, the fear is that what if it really destabilizes your performance? What if performance is degrading, not improving? What if something breaks while you're sleeping? These are all the questions that pops up into your mind when you're talking about AI, or when you're talking about giving keys to your production system. And in this talk, I'm just going to talk about the fear part of things. These things that one should actually ask, the question that people should ask when they let any AI solution touch your production system. So this basically is the promise and the fear side of things that one should needs to take care about. But before we go any further, let's first understand why this is actually hard and how we approached it, or if you are building your solution, how you can approach it as well. As you know, with PG18, Postgres 18, we have got like close to 400 parameters. Not all of them are performance related. and I believe it's like couple dozen of them actually are related to performance. But it's not like that you simply copy paste one configuration and paste it to another and it works. It's a very complex problem. Why? Because they are interdependent. So parameters don't work in isolation. But what I mean with that is that if you change or if you touch one parameter, it can have a ripple effect or a butterfly effect in any other parameters. So you should be aware of what you are doing, and that's why this problem is very hard. We have got many experienced DBA tackling this problem, and still, even with like decades of experience, they stumble upon a configuration or stumble upon a production issue that can you take them hours or even days in solving that. Plus, as I was saying, environment matters. So, for example, a very quick example that I always want to give is related to JIT. As you know, with Postgres 12, JIT is enabled by default, and for complex queries, that's the right things to do. Postgres actually thought about it, and they saw that okay, people with analytical workload or complex queries workload, this can really benefit performance. But when you talk about RDS, what RDS did is that they disabled that. Why did they do that? They analyzed their customer workloads, and they realized that their customers are mostly OLTP. They're using OLTP workloads. So they disable that by default. So if you don't really know, or if you're just copying the configuration, so if you are running a kind of workload which is actually very similar, nothing changes, and you just copy your self-hosted configuration to RDS, it can actually be very harmful. And we have seen this in many production environment. People have actually reported it. There are many blogs around it. I'm not going to, talk about this here much further because this is not a JIT related talk. I'm just going to, sharing why this problem is hard. So that's the thing. That is why this is very complex, and AI based solution can really help you. That is why people are trying to solve this problem using AI. How we researched, how we approached it in our part of the world. We basically, tested it in many environments. We tested in variations. We tested in Aurora, RDS, GCP, Azure Flex Server, CNPG, Kubernetes environment, multi-HA environments using Petroni, using EPAS, many folks, or any other, many variants that are in the market. And it tested very rigorously. We also tested using different workloads. We have tested with HammerDB, Benchbase, PGBench, and many other workloads. There is ClickHouse as well with their own workload as well, which we have recently tested as well. So the point here is, if you are building your own solution and if you're trying to create one, you have to take care of all those things, and you have to, have this kind of mindset. You can obviously add in these situations, but my point is how we did it. In our part of the world, we try to do all those things, trying different benchmarks. We have in our in-house benchmarks, we test frequently, rigorously. Whenever we add any platform, we try to add all those things. The goal here is to understand what breaks and when and how to prevent it. So the idea of this talk was safety related, is actually safety related. So when you talk about safety, you need to first understand what actually breaks. So when it breaks, you then actually are able to fix it. So let's move on with this. In this small 25-minute session, I'm going to mainly discuss 5 challenges. I call it challenges. You can call it trap. You can call it whatever. Whatever phrasing you can like. But for me, these are the challenges that we faced. One is obviously the main one, which is the memory problem. Memory is a very big constraint when it comes to tuning. If it's too high, it can cause an OM kill. If it's too low, it can be you're leaving performance on the table. Then their second task is related to exploration. So that is, I will not go further much here because there is a separate section around it. But cost, basically, exploration comes at a cost. If you spend too much time, it can actually degrade performance. Then there is a confidence problem. So whatever recommendation that you are giving, you need to be confident enough that it's actually valid or it's actually good. Then interaction problem. I briefly touched in my intro that parameters don't work in isolation. So that's a very big problem. And the final is actually blind trust. This is not the challenge, but obviously if you are evaluating any new AI solution, you can't really trust blindly. That's also a challenge. You have to have a checklist that needs to pass once, and then only then you can actually trust them. So these are the 5 things that I'm going to go through in this session. So let's talk about challenge number 1. the challenge number one is basically the very, the most common one, which is basically memory. So before I go into it, this one, what is basically memory? As you know, we have got shared buffer, we have got work mem, we have got effective cache size, plus we have got max connections. As you know, every connection does hold a memory. Every query has every query operation has a memory bound to it. So this is a very big problem. This can easily get out of hand. So what I mean get out of hand is, I'm going to show a small example here. But what I'm trying to say is that if you don't have memory guardrails around it, if you're not taking care of the memory, that means just recommending a small change in your, if even a max connection type in your connection string or your work mem, things can, you can face an OM kill. And if that happens, your production systems can simply crash, and that's obviously not right. So just to give you a small example here, what is the memory trap? So this is a very basic, we have seen this is a very basic RDS system with DBR6 4x large with 128 GB RAM. 128 GB RAM in a production system is pretty normal. And as you know, RDS comes with like by default 25% shared buffers. So shared buffers are set to 22 GB. Setting work mem to 64 MB on a production system is also pretty normal. Standalone, it's like a very basic thing. Nobody can actually, you can't really say that, okay, it's very high or very low. And just, we have seen this. You have a query that has got a simple three operation query. When I say three operation, I mean it has like a couple of hash joins, a simple index job, simple hash join and as SQL join, and that actually is a memory operation. And if on a production system you have your 500 concurrent user, that can easily translate into 128 GB. So you are already for a single query with 500 user connecting to your production system, you are getting into an OM kill. Now that's very dangerous. And now here I am not talking about any vacuum operation or any your headroom or any connection strings or anything like that. This is just from one single query. So that's how quickly, how immediately this can go all wrong. So that is why when you are building your solution, you have to have your memory guardrail around it. You need to know when you're recommending these memory related settings, you don't actually run into OM errors or any memory related errors. So how actually do that? What's the mechanism? It's pretty simple, very basic. You have to actually check, you apply, and then reject. What I mean with that is you first have to calculate. So when it comes to calculation, this is mainly related to your workload detection. In our part of the world, we have a workload detection mechanism. That actually means when we see the workload, observe the workload, we know, okay, what kind of workload we are dealing with. And that gives us our internal formula actually tells us that, okay, this type of memory search space will be good enough for this kind of workload. If you are building your own solution, you can have your threshold. We are setting our threshold around 80% or 85%. You can have it more aggressive or more conservative. The point here is you don't want to leave performance on the table as well. You don't want to even recommend lower memory. You don't want to set memory work mem or any shared buffers or any memory related operation too low, so you are leaving the performance on the table. And the beauty of AI is that it actually learns from over time. So if there is any unsafe configuration that you have recommended, and if you are recorded it, if your mechanism is recording it, then you will not actually go there and again recommend it. So this is just a principle here which I am trying to convey, that you just take care of when you're building your solution. You have to have your memory guardrail and follow these checklists. So this was our first check. The second check is, exploration comes at a cost. So this is something related to, it's a maze. So if I explain it very simply, imagine you are in front of a in front of a mountain, foggy mountain, and you don't know what's happening. You walk. It can be a pit or it can be a shortcut. So you don't know, but it doesn't mean you just don't go. You have to, if you want to cross the mountain, if you want to go to the end goal, you have to actually explore. But exploration comes at a cost at a time, which actually means there is a chance that you can fall into a pit, or you can, if that means that if you don't go there, it might not be a pit. It can be a shortcut. So you have to explore your search space. But how do you do that? What principles that you need to follow? Well, that's the thing that I'm going to explain. There are two things that I'm going to just explain here, but I hope that it's clear. It's a maze trying to find your, it's navigating the maze, and it's trying to find your best solution and how to go there. So yeah, one mechanism is obviously performance regression detection. As I mentioned before, when it comes to memory, so this is going to be a pattern for all the challenges. You have to learn and you have to record, and that is where AI actually helps you. AI actually, with AI, if you have built it properly, you learn from your mistakes and you record those mistakes, so you don't go there. So in the world of databases, you have got like many queries, right? So what we have seen is that mostly not every query is important for your workload. So if your workload has got thousands of query, there's a 80-20 rule that we follow, which basically means we follow the 80% of your query that are important. When I say important, whatever mechanism you follow, we follow at this point in time a runtime coverage mechanism, which is basically if your query is covering most of your workload, that is, we marked it as important, and then we just focus on that. So this is related to how you explore your search space. So if you're exploring, if your search space is smart enough to detect what queries they are tracking, then that's a better approach. This is one of the things that you can do. You can have your own set of algorithm, or you can have your own set of rules behind it. But the point what I'm trying to make is you need to have a performance regression detection mechanism. If you don't have that, you will just be falling into a pitfall or trying to explore the search space, which is not really important. At our part of the world, we have got fingerprint, which we call a fingerprint, which is basically top most important queries based on your workload. So we analyze the workload, we define what is important, and whatever it's what we feel is important for that workload, what query set is important for that workload, we just monitor that, and that is basically focusing your search space to that set of queries. So that's one thing. But here if you notice, I'm talking about performance, I'm talking about noticing, and I'm talking about your queries and then measuring the performance. But for how long? That's the latest part, validation windows and threshold. So that's another important aspect. So if you are in a search space and if you monitor it for too short, that and in time it will be, so maybe it was actually a shortcut that you just realize that initially for the first 30 seconds or 40 seconds you were there, you think, oh, it might be a pit, but it was actually a shortcut. That's a too short thing. But then if you think if you are there for a longer period of time, it can waste time. So you don't want to, whole point of your solution is to make it faster, right? So if it's not fast, it can cause too much issue, and if it's too short, it can again leave performance on the table. So having a proper threshold or a proper iteration window is very important. This is what I'm talking about, is basically your loop cycle. So you're testing your configurations, you're testing your data set. So but testing it too long can cause an issue, too short can also cause an issue. How we did it, we have, as I said, a mechanism to test a proper signal. So if we have some mechanism where we are having the signal threshold, so if the signal is stable enough and the threshold, if it reaches that threshold, only then we move forward. And we have obviously some time constraints around it as well, where we simply say that, okay, if it is taking too long, we simply error out. So you have to have an error out mechanism as well. The third challenge that I want to talk about is obviously confidence problem. To explain it very simply, if I hit a bullseye right now, you will not start calling me Robin Hood. So what I mean with that, for me to be a good archer, I need to hit it consistently. So that's why statistic rigor is very important. That's the confidence problem. That means is that you can't really announce that this configuration or these parameters are good without testing it again and again and again. So you need to make sure whatever you are recommending is actually valid and it's actually reproducible. So that's another challenge, that when you're building your solution. How do you do that? You need to have multiple runs. One run is not enough. You need to have multiple runs. You can have 5 or 10 or 30. In our part of the world, we do 30 iterations, and in 30 iterations we have found it that for certain kind of workloads, 30 is like a good sweet spot where it is not too long or it's not too less. And during that 30 iterations, we have a statistic rigor maintenance where we validate the results, and we are confident enough that, okay, this is the configuration that will actually give you constant results. There can be a bit of noise. There can be a 5% or 10% variation, but not much. So you need to have a reliable mechanism or a configuration mechanism where you can do that. So where can obviously be a bit of noise as well, but with your statistic rigor in place, this can actually reduce these things. Again, the another aspect of this is obviously having a rollback and mechanism. As I said in the previous section of exploration comes at a side, you need to have your rollbacks in place. You need to have a mechanism where if if your configuration that you are actually recommending is not really valid, you have to have a rollback mechanism. You have to have a section where you are comparing to your previous configuration. If that was better, then you have to roll back immediately and go to the previous one. So you have to have this mechanism in place when you're recommending the configuration. This all ties into how you're building your solution or how you are creating your a solution here. And all this ties up with monitoring. Monitoring is one part where you can't make decision based on that. So when you are building your tool, you need to have this. We have Grafana, we have Prometheus, we have like many other Delibo and many other tools, pgstat statements and pgstat plans, which tells the plans and all those things. But when you're building an AI solution, you need to have these kind of things in front of you. You need to know your TPS, you need to know your query runtime, you need to actively monitor your memory because you're making decision based on this. Plus, there are many disk related things. Your IOPS, you have got P30, P50 tires, you have got many limits and all those things. So all those things matter when it comes to these kind of things, right? So monitoring for safety is very important. The other challenge, which is actually our final challenge that I would talk about, is the interaction problem. I think about it as like tuning up the band. So if I start playing drums or a piano, it will probably, I'm not to say probably, it will for sure be a noise. It will not be a music. So a good musician will obviously know how to tune it, how to tune up their band, so it can be good to your ears. Whereas if I start playing, it will just be a noise and you will just kick me out of the room. So that's how the tuning is. It is like an interaction problem. If you tune one knob, if it's not properly tuned, it can just cause many issues. So it is important that you take care of all those things. And when you tune one thing, you should know, okay, what's the effect of the other parameters. As we have got very little time, I'm just going to share one production example. So this is one example which is very well reported in the blog. This is an astrophysicist production system. What they did was they just disabled one parameter, which was enable sequential scan. They wanted to enforce index scan. They didn't know that it will inflate and their plan cost will change to 10 billion, which in turn enabled JIT. Now the JIT threshold in Postgres is like, I believe, 100,000. But the plan inflated to 10 billion. This meant that JIT was enabled. Because JIT was enabled, the query runtime was from like 6-7 milliseconds, 7 seconds, which is really what you call very off. And the solution was actually just changing the threshold, changing your statistic, updating your statistic and changing that. So this was just from one parameter. They didn't do anything else. They just, enforce index scan. But enforcing index scans cause this ripple effect, the butterfly effect that I talk about. So it is very important that you know about the ripple effect and all those things. And you have to have a mechanism or understanding of parameters, how parameter interact with each other. You can read more about the blog that is, mentioned here, Tim the Postgres. This is again a JIT example, but it can be anything. Finally, your final challenge is obviously evaluating AI tuning solutions. So this is one of the most important thing, to be very honest, blind trust. I talked in my initial slide, not trusting blindly to any solution that is asking this. So you need to ask these questions. If they don't have safety guardrails around it, if they don't have statistic rigor around it, if you don't ask, what happens when the failure comes, failure will happen. Because we are exploring the search space. So it's not going to happen like there's not going to be any failure. There are going to be failure related to your performance. It can degrade your performance or it can cause your memory issue. But there needs to be guardrails around it. If a solution that you are evaluating doesn't have all those things, or if they are not recording all those things, if your rejected configurations are not being recorded or logged properly, then don't trust that solution. So you have to know what questions to ask. You have to ask these questions. You need to know how the memory is basically captured, how are the regressions detected, what happens when the failure actually happens. And if the solution is just saying just trust AI, or there is no monitoring tool, or there is no explanation or logging happening, then just don't hand over your keys to your safe, which is actually your production data, which is very important. So what we learned today is basically the safety engineering pattern. Safety engineering obviously requires multiple layers. You have to monitor your resources. As I said before, you need to have your rejections recorded. You need to have your performance validated, and you need to have your statistic rigor. If you don't take care of all this, then when you're building a solution, then this is the blueprint. If you don't do this, miss any one of this point, then your solution that you're building will unfortunately be very faulty. So what's the chunks of this talk? The chunks of this talk is that obviously design safety mechanism first. As I said, everybody wants to be fast, but when you want to be fast, you need to have fast breaks. So always take care of safety first. This can in turn turn your solution to be fast, and you will be able to get the results as soon as possible. So design safety mechanism first, and document and share what you learn. So community is very important. Community benefits and you learn more. What we have been doing in our part of the world, we have been very actively involved in community talks and community gatherings, and trying to discuss all those things. And we have seen, so few of these mechanism our solution has improved came from the community discussions and community talks that we have. Test failure first. Failures are important. So don't only work on the happy path. Try to test rigorously. Try to push your benchmarks to a very unsafe place, and then build your safety solution around it. When you have your breaks faster, then rest assured your AI solution or whatever solution, the mechanism that you're building will be very fast. And that's what we have seen. So what is the key takeaway? Well, AI tuning needs safety engineering. The takeaway for this talk was basically, you need to have safety engineering, robust mechanism around it. AI can tune your database safely with the right safety mechanism around it. So if you don't have your safety mechanism, then AI can be very bad for you, and it can actually harm. But if you have got your safety brakes on, then believe me, this can actually be very faster. So I guess we are at the end. Thank you so much. For any questions, pop your questions on our Discord channel, and thank you.
Thank you. It was a very good talk. Especially some of the concepts that people find out the hard way, like hitting memory limits and how hard it is to actually predict how much memory PostgreSQL would use.
Yeah, it feels like unfinished business in Postgres itself to me. Hope we can shave some of those dangerous edges off.
Exactly. And speaking of dangerous edges, wear some socks, protect your feet, get the socks, and do the survey for the talks so that the presenters can get feedback on how they did, what was good, what was bad, and to know that you enjoyed it, because since this is a virtual event, they can't see your faces in a room as with normal conferences. So this is a very important step. And what I like is that the previous talk slightly segues us into another topic related to, all those design things that come back from the early days. Josef Machytka will talk about the multiverse of connections, so connection pooling, process per connection model, and how PostgreSQL handles all of that. I'm really looking forward to this.
Interesting stuff.
Okay, let's roll the video.
Hi, my name is Josef, and I want to discuss scaling Postgres multiprocess architecture, because it's not just about throwing more hardware at the problem. Each connection carries some hidden tags. And it could be Linux level memory and CPU overhead, or Postgres level MVCC and locking constraints. So to manage high performance workloads, we need to understand these limits. So join me for a deep dive into these topics, because we shall stop guessing and start tuning our systems. So let's start with Linux and Postgres in the multiverse of connections. I work for a German company called Credative. We offer support for open source products. Postgres is one of our biggest topics. And we also offer complex solutions based on Kubernetes and Proxmox. My whole life was about the different types of data processing. I worked with a majority of big databases, with NoSQL solutions, with different solutions for data ingestion and ETL processes, built some data warehouses, lakehouses, and lately I do similar stuff also with AI and machine learning. If you would want to connect with me, here are some links to LinkedIn, articles which I have on Medium, recorded talks on YouTube. So don't hesitate, contact me, we can discuss these things. Let's dive into Postgres multiprocess architecture. This solution was chosen in 1990s for higher stability, and those processes are separated, isolated, very safe, but it also means that they cause some overhead on CPUs and memory usage, and they need some interprocess communication, which is done using shared memory on Linux. This diagram explains roughly how it looks like. So we have here two different processes with different process IDs, and each process has its own private code, data, heap memory, stack, and other stuff, and also isolated virtual address space. And they share kernel resources and shared memory. There are ongoing discussions about switching Postgres into thread-based architecture. But the problem here is that those threads, they run always in scope of some process. So here we can see that actually that heap memory will be used by all threads running inside this process, which means that developers must be really cautious to not overwrite parts of heap memory which are used by other threads. As I learned from Boris Momjin from his talk on German conference, there are plans to implement mixed architecture into Postgres to have something similar like Oracle. So we will see how it will turn up. In Linux philosophy, everything is a file. So also interprocess communication is implemented as special file system, so-called TMPFS file system. And there are three ways how to access this TMPFS. The oldest one is so-called System 5. A new so-called internal mount inside the kernel is mapped as def0 mounting point and used by mmap function. And there is also this def-shm directory, which is also really important for Postgres, because here Postgres creates files for interprocess communication. We can find here files for asynchronous I/O interface, for parallel queries, and we can also, as users, interact with this TMPFS. But we must understand that this is direct access into memory. So by using it, we are actually eating the memory on the machine. When it comes to memory, this is another quite important limitation of scaling Postgres to many connections, because 64 bits virtual address space must be mapped to physical addresses. Currently, not a whole 64-bit range is being used, usually 48 up to 57 bits. And that thing is implemented in very lightweight hierarchical tree of 4 or 5 tables, and they contain pointers to the next level or physical mapping. And those are these tables. So on the top, we have page global directory, and those three tables on the bottom, they can contain physical allocation. So page upper directory contains allocations of huge pages in 1 gigabyte size. Page middle directory allocation of those 2 megabytes huge pages, and that lowest level page table entry maps those standard 4 kilobyte pages. In Postgres, every process is created as a fork of main postmaster. Fortunately, this forking process is quite lightweight. So, and even if postmaster already uses the whole capacity of shared buffers, not all that mapping is actually copied into newly created connections, only necessary parts, and that child process fills its tables when it does not find physical mapping in translation look-aside buffer. Shared buffers can use huge pages and actually should, as I will show on further slides. Connections use only those small standard 4 kilobyte pages. And we have also this mechanism of transparent huge pages in kernel, but it should be disabled for Postgres because it can cause quite big performance issues. And I have a different talk and also a workshop about these issues. So if you want to look at my slides about shared buffers. And here is explanation why that mapping in huge pages really matters. Because if we neglect it and we use standard 4 kilobyte pages for mapping shared buffers, and then for 1 gigabyte of buffers mapped in these standard pages, we will need up to 2 megabytes of PTE table, which actually with 8 gigabytes buffers and 1000 active connections can theoretically grow up to 16 gigabytes of PTE tables. It sounds like a mistake, but look at that article which is linked in that blue text. It's a Percona article where they analyze these things on a big database machine, and in their case, those PTE tables reach something like 25 gigabytes. So mapping shared buffers in huge pages is a really good idea. And here we can see the difference. If we map 1 gigabyte buffers in 2 megabyte huge pages, we need just 4 kilobytes of that PMD middle directory table. So with the same example, 1000 connections and 8 gigabytes of shared buffers, it will grow only up to 32 megabytes of PMD tables, which is significant difference. And here are two commands which we can use to examine situation on particular machine, either on the whole machine in that meminfo file or for specific process in its status. We have now a new toy called the NUMA architecture. Originally, we had symmetric architecture, meaning all CPUs access the same memory using the same memory bus, which with growing number of CPU cores actually caused huge problems on that memory bus. So we now see internally machines being divided into NUMA nodes with dedicated CPU cores, which have each own memory banks and local memory bus, and also remote access between those NUMA nodes. So it's more or less something like several physical machines connected internally with very quick bus. But this remote access is always slower than that local access inside specific NUMA node. Linux kernel offers some NUMA balancing mechanism, and it can automatically migrate memory pages and processes between those nodes. And according to benchmarks, it seems to be good enough for general workloads. Question is, what about Postgres? I had great opportunity to test Postgres 18.3 on Phytium machine, 64 cores of ARM64 architecture, divided into 8 NUMA nodes, 4 nodes with memory and 4 nodes without memory. It was very interesting configuration. Here is diagram showing this situation. Those green nodes, they have memory, and those gray nodes are without memory. Each node has 8 CPU cores. And in firmware, there is this table of NUMA distances, which shows theoretical penalties if we access resources across those nodes. So idea is that when we access resources on the same node, and that distance is marked as value 10, and with each jump between those nodes, it adds additional 10. So when we look back in this diagram, we see that worst case scenario here is communication between node 0 and node 6. And it is shown in this distance table as penalty 50, that red penalty. But these distances are theoretical. So in scope of this problem, we must also discuss binding policies on NUMA architecture, because we can pin either memory or CPU to specific NUMA node or list of nodes. And for Postgres, this is a hard limit, because when we pin that postmaster process, then every fork will inherit these policies. So Postgres will use only those resources which are dedicated for it through these binding policies. And therefore, if we want to pin Postgres to specific nodes, we must also make sure that resources are sufficient. I tested all pinning variants on that Phytium server, benchmark some mainstream types of workloads which I could think of. And at the end, I actually realized that those results are not statistically significant. Benchmark results were inconsistent. And from my perspective, for those types of workloads, I could test that NUMA latency was insignificant. So that distance table actually badly exaggerates. So what I found is that pinning Postgres to specific nodes is useful for workload isolation. So we can, for example, run multiple databases on one big machine and pin these different databases to different NUMA nodes, and that way isolate them. So recommendation is to use this interleave NUMA policy, either for the whole machine or those few nodes which we want to use, because in that ways those processes and their memory are distributed evenly across those dedicated nodes using a round-robin policy. Context switching and Linux scheduler are another interesting problem when it comes to too many connections. Here there is some diagram, quite simplified, but it's still difficult enough, which shows how that context switching works. Generally, I think we understand it. CPU core runs first process, then that run is interrupt. The whole status of process is being saved, and then another process is being loaded, gets some runtime on CPU, again interruption, and the whole game is being done as many times as it is necessary. And here comes question of different schedules on Linux, because in these days we witness a big change in this schedule. Originally, we had this completely fair scheduler, and idea was philosophically quite nice. Let's give every process exactly the same share in exactly the same moments, which is shown on this very simple diagram. We have 3 different processes, and we can see that the characteristic of that load is completely the same for all 3 processes. But those processes are different, and especially in these days when we get quite quick data in some cases, which in this case is that process 1 audio stream, those are processes for which latency matters. Therefore, starting from Linux kernel 6.6, we have new so-called earliest eligible virtual deadline first scheduler. It's amazing name. I really love it. But it precisely says what it does. It gives every process as much as a small latency as possible according to calculated needs of that process. So the whole idea is depicted here. Now we can see that these 3 different processes are processed differently. Again, in a longer scope, each of them got exactly the same runtime on CPU, but it is structured differently. So that audio stream, which is very sensitive to latency, gets processing time more often with shorter latency. Of course, that processing interval is shorter in this case, but it improves the whole behavior of that audio stream. On the other hand, that process 3 compiler really benefits from longer uninterrupted intervals of CPU runtime, so the whole thing should run much better. And as I said, that change comes with kernel 6.6 and newer. So we now see this change of behavior of latest distributions of Linux. From Debian 12 used the old scheduler, Debian 13 jumps to new scheduler. The same with Red Hat Linux version 10. And as I know from discussions with clients, they already see differences in behavior of Postgres when they upgraded Linux version, and suddenly performance of Postgres was better, even without any changes in Postgres settings. So problem with that old scheduler was that completely fair scheduler was actually sort of unfair to very short bursty workloads, very short transactions, very short selects. And that average fairness was actually hurting performance here. And that new earliest eligible deadline first scheduler actually prioritize processing of these bursty connections. So we see better latency and they are being processed earlier. And there are some discussions about machines with predominantly analytical workload, because there could be some problem with more context switching, but we can actually tweak it using Linux policies, so we will see. And people often ask, okay, this is nice, but how many connections we shall have per CPU core? So we must think in scope of active connection on one CPU core, because this is what makes CPU to do real work. So when we have typical transactional workload on modern SSD storage and shared buffers in huge pages, then up to 4 active connections per one CPU core is definitely okay. If we have those very short bursts of transactions, very small transactions, then even up to 6 or 8 could be okay-ish, but it really depends on workload. With older hardware and without huge pages, of course, throughput goes down. For analytical workloads, we must use really one connection per one CPU core. If we have parallel workers, then we must also dedicate cores for each worker. We also need to understand memory usage per connection. So this is typical situation on machines that output from top command shows one connection, and residence size is huge, 8 gigabytes. Problem is that this mapping is distorted due to mapping of shared buffers. And for understanding it, we must go into so-called SMAPs kernel interface. And here is the output of a simple script which scrapes data from that SMAPs interface and pivots them. And for our purposes, that fifth line, def0 deleted, is most important because here are all those huge numbers. And this is the way how shared buffers are being mapped into physical connection. When we look at those other numbers, residence set size and mainly proportional set size, we see actually very, very small numbers. So when we now do this magic for typical situation, when we have many connections with residence set size in summary exceeding physical memory on the machine, and we go into SMAPs interface and actually remove that def0 deleted line from our calculations, we now finally see what is the real memory usage of those connections. And there are some differences, and I will explain why, because this is connected with the mystery of workmem. We all know workmem, but to actually show how it works, we need some scripts which will repeatedly scrape SMAPs for connection during query run and plot results. Here is great how it looks like, but don't worry, only that second and third graph in this whole mess is actually important because they show anonymous and heap memory. So if we run very simple query with default settings of workmem 4 megabytes and that data set fits nicely into workmem, we can see this in our measurements. Very short, quick burst of memory usage, and that's it. When we plot it and scale it better, we can be surprised that actually workmem was used 2 times in this very simple processing. Not 1 time, as it is usually discussed in different articles, but 2 times. Which is not bad. Postgres used as much memory as it needed, but it also means that calculation based on one workmem are not exactly safe when we want to understand memory usage. So let's try this thing with a data set which does not fit into that workmem. And here we see different characteristic. But what is really important is that heap memory staying high at the end of processing. When I plot it, summarize it, workmem was used even more, 2.2 times. But that heap memory stayed somewhere around 1.5 workmem, which is something we would not expect. Problem is with the mechanism of heap allocation. At the end of that query processing, connection created some small objects on the top of heap, and that object will stay there until next query. Postgres actually deallocated memory which is below that small object. But since it is heaped, it can only grow up and go down from the top. Even though Postgres sees these deallocated memory chunks as free, Linux actually still has these pages marked as dirty residence set size pages for that process. And this is another problem. What can happen with these connections, especially with small workmem size. There are 2 other internal limits of Postgres. One of them is scaling of multi-version concurrency control snapshot. It was improved in Postgres 14, and throughput is now stable. That blue text is linked to article on Microsoft blog. It also shows this diagram, how throughput is now better, but with too many connections, this is still significant bottleneck. And last but not least, there is a bottleneck for too many locked objects per session, which was significantly changed in Postgres 18, but in Postgres 17 and older, it allows only 16 objects per session being locked locally using fast path mechanism, and everything else above it required access to central shared lock table, causing huge spikes of lightweight locks. So using latest Postgres in this scope is definitely a good idea because we can actually set it according to our needs. And that's it. Here are a few pages summarizing what I already said, but I will not repeat it. And that's all what I wanted to share with you. I will be on Discord, so don't hesitate to ask me. Let's discuss this stuff. And thank you very much for your attention.
Thank you, Josef.
Thank you, Josef. Yeah, really interesting tour of operating system resources that Postgres uses too many of.
True. And a long way ahead of us of wrangling all of this into the modern computation space, right?
Yeah, I mean, we'll get there. We will get there.
And while getting there, get some socks. It's always nicer to work with socks and leave this feedback for the speaker. You can do this by scanning the QR codes and filling out the survey. Also, leave a survey for the event.
Okay, so next up we have Paolo Melchiorre, who's going to be talking to us about generated columns in Postgres. So let's dive into that.
Hi everyone, I'm Paolo Melchiorre, and today I'm talking to you about the Postgres generated column. I'm doing that using some example and using Django ORM and some beautiful picture from Italy to show you how to use this fantastic feature from Postgres and Django. Okay, so let's dive in Postgres generated column using some example. But first, we have to know what generated column is and when is being added in Postgres. I found out that generated column has been added in Postgres 12 in 2019, but so it's not as a recent feature, but in the recent Postgres 18, the new virtual optional has been added in it. And this is something that we can see during this presentation. Unfortunately, I found out reading the Postgres documentation that this is the only example you can find about the generated column, and it's enough to you for understand how you can use generated column, but it's not enough to think about so many different options you can have to use it, and you can use it in your project. But before showing you more this example, I want to present a bit myself. I'm Paolo Melchiorre. I'm Python Django developer. I'm from Italy. I'm on the board member of the Django Software Foundation, a PSF fellow. I organize and help to organize PyCon Italia, which is this conference that we organize in Italy and will be at the end of May this year. I also founded Python Pescara, a local community. We organize monthly some talks and some beers. And also I'm involved in the community, trying to help as a navigator in the Django Not Space program and organize various Django Girls workshop. So as you can understand, I'll try to show you some example of Postgres generated column using Django as a project. And Django has also a very good documentation And one part I like the most is this one. We can read in the performance and optimization section that's using Django in the right way. You have to try to use the lower level if you want to be faster. And speaking of Django and the ORM, the lower level is typically the database. In fact, I like the most using in the best way the database, and today we are going to use Django with Postgres, of course. I find out reading about this new functionality in Postgres, generated column, and I notice that is something that is computed by the database, so it's very fast compared with Python. And reading more about it in the internal, I found out also that was something already always updated, that requires no trigger, no Python code, so something very aligned with the principle we just saw before. And after discovering this functionality, I wanted to share with some other people in the Django community. In this picture, I'm at PyCon.de in Germany, specifically in Berlin. And after the pandemic period in 2022, I met Marcus and Mark here in the picture, and I tried to share with them this new functionality and the idea to implement and use it directly from the Django ORM. In fact, they give me some feedback, good feedback about this idea, and I shared also with a wider, large community of Django, writing directly from the conference and proposing them to add a generated field feature to use the generated column in Postgres. And I received a very good feedback. As we do in our community, I opened an issue and I share with them my ideas. We received some feedbacks and some criticism about what we want to do to use this functionality. And then we moved to the implementation. As you can notice from the dates on this pull request, it took us a few months to open the pull request, to find all the bugs on the implementation, and to see how good was the ORM layer on top of the generated columns. And in this process, I had not time or energy to open myself the pull request, but I was involved in the reviewing the pull request and trying to find a lot of edge cases that, as you can see from the conversation, has been a lot. But at the end, we finally merged it in the Django 5.0. And just 1 year after we originally started talking about it. But as for the Postgres documentation, unfortunately, also in the Django documentation, which is quite good, this is the only one example that we were able to put in it. The Django documentation, as the Postgres one, is quite large, and I can understand that having multiple examples for every functionality would be difficult or too much for everyone to read and to update. So I decided to extract all the edge cases and the tests I did to helping in the development of the feature, and I published a series of articles to explore on my website how to use the generated column with Django, with SQLite, with Postgres specifically, and also with some geographic functionality using GeoDjango and PostGIS. Before showing you some of these examples in the next minutes, I want to quickly share how the layer of the Django ORM is on top of generated column. The generated field is a new field in the ORM. It relies on the computed value, and it relies also on the database to perform this update with no extra code and to have the data always in sync. We have some attributes to create a generated field. You have to specify the expression that you want to have that calculate the final value that has a lot of different implementation. We have to specify the output field, which is the type of the column we are going to create. And we have also to specify if the column is persistent or not. And until Postgres 17, the only way we wanted to use the generated column was the stored column. But from Postgres 18, now we can also use the not persistent, the virtual one, which is quite useful to perform a lot of writing and few reads, because the value is calculating when you read the value and not when you write in your database. Okay, let's start seeing some example here. I want to share with you some picture from Italy, where I'm from, and this is the first picture from this building, the center of Rome, which is circular. And since Roman liked a lot the circular form, I created a class that is a circle, of course. This is a Django model. I tried to use some simple class to show you how to implement some generated field. It has only a radius field, which is a float, and the generated field calculates automatically the area. We are already using some function from the Django RAM, which are at the same time some function in the Postgres layer. We are calculating the area using some function, some constant. And also I put the output field and the percentage value. The string representation for it is only needed to show you the result of this calculation. And this is the SQL code that the ORM from Django will generate for us. It's very similar to what we just saw in the Django layer, but it's SQL. It used similar function and similar variables. If we go in the Django shell, we can create directly from the shell, for example, a circle instance, giving some input for the radius, and we can see directly the calculated value for the area. It's quite easy to show what has been processed and run on the Postgres side using these two functions, and this is the SQL code that has been run by Postgres. We passed value in insert into, and we received in return the ID and the area value. So go and see another picture from Italy. This is a pastry in Venice. We can see on the glass here some piece of chocolate with some phrases. So the next class we are going to see is an item. I put on this item a price and a quantity. In this case, I also define a default for the quantity, which is a new functionality from Django 5.2, and it permits us to use the generated field in quite a small different way. So the expression is quite straightforward, and the output is similar to the price field. But the code we saw in SQL is a little bit different from before. We can see there is also a default and a check on the quantity layer. And the generated column is a multiplication from the price and quantity. But we can use in Django in two different ways now. We can specify a price and having the result from the total, but we can also specify a quantity directly. In this case, the result is different. Let's change city in Italy. This a picture from Bologna is the location when PyCon Italia will be organized this year. And this is quite in the center under the two towers in Bologna. And this is a semaphore. And every time I think about semaphore, I think about statuses. I created a class which is an order with two date times. One is nullable, one is mandatory. And I created also a generated field to represent the status, which is quite simple, but it can show us how to use case, value, and when attributes to calculate the status based on the presence of the two date time here. So the conditional case is quite simple. If we have the payment date time, we can set the status as paid. Otherwise, we use the default value which is created. So let's go and see what is executed at database level. This is the SQL. We have the time here, and the calculation use the same function as before we saw in the Django ORM. It's very easy to read. If the payment is not null, then the status is paid, otherwise it's created. Let's move the Django shell. The creation here is straightforward. If we only put the creation date, we have this created status, or otherwise, in the second example, we have the paid one. Okay, until now, we saw very simple example that can work also in other databases like SQLite, but Django has a specific coding module specifically for Postgres. So let's activate it. We only have to add this line in the settings of our Django project. And after that, we can deep dive in what we can use from that. This is another picture from Venice. It is a Qualta library. It's very old and funny to visit. It's quite crowded with books, and it's very difficult to find some information inside the library. But I like this example to tell you about the JSON field. In fact, sometimes we put in JSON field a lot of information which is quite difficult to find. In this case, I created a package class that help us to represent packages, Python packages. We can put a name on it and also put in the JSON field all the information about the packages we can retrieve from the Python website. Let's see how we can use it. But before we saw the generated column here, try to get the information key from the info in the data in the JSON values. To retrieve the information, I use Python standard library to get Django from the pypy.org website, specifying only the name. And then after downloading all the JSON with all the information about the packages, multiple version, we can create the packages, passing the JSON. And as you can see in the result, we see the Django packages and the latest version of the packages, which is the 6.0.4. Actually, we can implement it in a different way. For example, we can have only packages with the JSON field and a char field for the name, and use a Python property to extract the version from the JSON field, and it works quite well. But if we have this type of implementation, when we retrieve all the packages from our database, our column, the table, sorry, and we see that we retrieve all the data. It means we retrieve a lot of JSON information. It's not required because we only want the version. So maybe we can implement using an annotation in the Django ORM, and under the hood, we see here in the SQL that we are using only the version extracting directly from the JSON field. But if we use the generated field, this is the SQL we will have. Is simpler and is also faster. In fact, I try to benchmark locally on my computer, and with multiple type of packages, you can see from here that using the generated field is very, very fast. This is a logarithmic representation of the differences, but of course it can be different on your computer, but I think more or less you can find that generated field is quite faster. This is another picture from Venice. It communicates me the union from people, and I want to show you some implementation of a class with using concatenation. A simple example for a person with the first and last name and with the generated field, we can concatenate the two of them using also a space in the middle, and the result is here a concatenation of this string. The final example is quite straightforward and it's not so complicated, but we can also use concatenation to create something more complex. For example, we can create from a person class a JSON representation and change maybe the key and the name or the content using uppercase or concatenating only the first and last name. In this case, we have an initial. This is what happened under the hood in SQL, and this is what we'll see if we try to create and represent a person. As you can see, it's quite different from before, and it's a different way to represent it and to have JSON representation directly in the database. But move on to Milan, another city in Italy. This is one of the oldest library in Milan. It's full of books, and it will be interesting to try to read everything on it. I created a new class, a quotes, where we can store the author name and some quotes and text from the quotes. What I try to do here is to search on it and to create a generated field which contains a search vector to perform some full text search on it. In this example, we are trying to create a quote from Plato, and we can see that after creating it, we can also list the search vector, which removes some stop words and common words from the sentence. And if you perform a full text search using a plural and in having in the text a singular form of the same words, we succeed and we have a result. We can decide also that having the books in different languages, we can define the languages in a field, a different field, and we use it in the search vector. And this is the SQL code that we have. But if we perform it, we will have a error. As we can read directly from the error, the problem is the expression is not immutable. So to avoid doing that, I use the case and when function that we just saw before, and I put every languages I want to use here. And this is actually what we are using right now to avoid the immutable limits in the Django website search. As you can see now, we have different quotes in different languages, and in every case we have a representation on the vector field. Also in the case that there is some languages not supported by Postgres, like Latin. This is a beautiful hotel in the Como Lake in the northern Italy, and to book here you need, of course, a booking class. In this class we have only the start and date field, but we can generate with using a data range function date range field. It's not implemented already in the Django or RAM, but we can create it this way, and then we can see out its represented in SQL code. To use it, we can create a booking object, and then we can see that it's straightforward to filter all the bookings using directly a date and using the functionality of the range. We have moved to another city in Italy. This is Trieste, and in the Miramar Castle, we can see this globe. We can use also GeoDjango and its geographic functionality, just activating this in the setting the country.js. This is one of the oldest map in Italy that represents the new words, and it's quite interesting how many things we can represent. Using, for example, GeoDjango, we can represent a city with a name, a point, and we calculate various things using generative field, starting from the point field. We can use PostGIS and GeoHash to represent the hash information from a point, like in this way. And creating a city, you can see the GeoHash, which can have multiple applications. We can also create, as before, with some concatenation, the GeoJSON representation for the city. And using the PostGIS function under the hood, this is what we get. Only defining the point, we can have a GeoJSON representation that is stored in the database. But since we are speaking about maps, we have to move away from Italy. And this is a picture from the straightest roads in Australia. It's 90 miles long and straight. And to represent it, we only need a line string. In this case, we have a route, which are a name and a line. And we can calculate the length of the line using the generated field in this way. As before, it used a PostGIS function. And if we put the string and the representation of the route, we have the calculation of the kilometers in this case of the route. Okay, let's jump the world, and now we can go in Colorado. This is a beautiful picture of the states. In a while, I will say you why I took this picture to represent a state, because we can define a state border using a polygon and using a generated field to calculate the area of this polygon, which is the state representation. Under the hood, the SQL use the PostGIS function to calculate the area, and this is the square kilometer for the Colorado state in US. I choose this one because more or less it's a rectangle. It's very simple representation of the state. It's not exactly a rectangle, but more or less it represents it. So I used to I use the generated column because it's very simple. It has consistency, and you can use directly from the database. You can use directly in Django, but not only in Django, and it gave you cleaner and safer models, and it works also in different database, in different backends, and it's very great for real-world apps. My presentation is released with a Creative Commons license, so you can download it from our website. You can find my contact here, the QR code that get you to my website, paolox.net. And to finish this talk, I will show you the picture I used in so many backgrounds, which is these beautiful lakes in the northern Italy in South Tyrol. Thanks all for listening.
Great presentation and great pictures. Like it almost feels like traveling there.
Yeah. Yeah.
Okay. Like a broken record today. Go get socks. Fill out the survey. This has been our last talk, so also please remember to do the survey for the event itself. We are also curious of your feedback, me and Thomas and the rest of the staff that was preparing the whole event for all of you. After this live stream, you can still attend the conference. Like, we are not done. This is live stream 2. We have 2 more coming up for you. One of them will be later today if you want to stay up and watch it. Oh, and by the way, like right after the live stream ends, like I don't know, half an hour after it, all the talks should be available on the conference page. If you go there, open up any of the talks, you should see the YouTube links readily available to watch anything that you may have missed or want to revisit. This is where you can find those talks that I just mentioned. Gratitude to all of our amazing speakers.
44 people in total. It's a lot of people.
Yeah, a small village. And maybe let's look at the schedule for Livestream 4 on Thursday. There will be 11 talks in this live stream. It goes from 8 a.m. to 2 p.m. Central European. Do we have a reel for this live stream? I think we have. Let me just check into my show notes. I think we have a trailer for Livestream 1 somewhere.
Hi, I'm Charles Ferguson, and in this talk, you're going to learn about all of the ways that we're driving Postgres forward at Microsoft through open source cloud services and building amazing tooling for developers and database operators.
Hi, my name is Afan Dar, and in this talk, you will learn about how Microsoft is contributing to the open source Postgres project.
Hello, my name is Boris Mejias, Solutions Architect from EDB, and in this presentation, I'm going to try to show you how to use the JSON data type in Postgres for the best. Because some people have trouble with this data type, they even consider it evil, and they think that the B in JSONB is for beast. But we can tame this data type so that it provides you the best for your database schema, and that you're actually going to enjoy this data type and love it as much as I do.
So hello, my name is Thomas Wondra, and I'm here to talk about random page cost, one of the important configuration parameters in Postgres affecting planning. So if tuning Postgres is part of your job, you might be interested in this talk.
Hi everybody, my name is Adam Wolk. I'm a technical program manager at Microsoft for PostgreSQL. Today I'm going to talk about fuzzing PostgreSQL and knocking at its door, essentially. You will learn what fuzzing is, how to start your journey with fuzzing, and if it is for you, and how to approach a large, complex code base like a database.
Hi, so I'm Chris, and we're going to be talking about Postgres design patterns. So this is a talk primarily for application developers, and we're going to go through a number of design patterns that I've used across 20 years of using Postgres. The talk itself is going to focus on one particular application and all of the different Postgres features that I used to make my life easier as an application developer.
Hey, I'm Pamela, and I'm going to be talking about building a MCP server for your Postgres database. We're going to look at the range of ways you can build MCP servers, from very exploratory servers where the agents can send full SQL queries to your database and do all sorts of things, maybe things you don't want, and then look at fully typed operational servers where you can have maximum confidence in the SQL that's going to get executed, but agents can still get their questions answered. So join me to learn more about building an MCP for your DB.
Hi there, my name is Matt McFarland, and I work on Postgres developer tools at Microsoft. This talk is about how our work around the VS Code extension for Postgres management is moving to a new set of tools to support new workflows that are emerging for database administrators and developers who are working on their applications. Please check out this talk if you are interested in AI-enabled workflows and managing your Postgres database with them.
Hi everyone, my name is Christian Miles, and I've been working with graphs and graph databases for about 15 years. My talk is about a Postgres extension called Apache Age that helps you run graph workloads on top of relational data stores. I'll be walking through the graph database landscape and where Age fits in and how it compares with other extensions like PG routing. And then I'll focus on something I'm really passionate about, graph data visualization, when to reach for it, when to reach for Apache Age, and the pitfalls to avoid along the way.
Hey everyone, my name is Andrew Ruffin, and I'm a product manager at AMD. This talk is about the Azure infrastructure choices you have and how that choice can improve your Postgres performance by over 60%, including the economics you care about day in and day out. This talk is best for database administrators or IT decision makers who are looking to optimize their cloud footprint when it comes to Postgres.
Hi, I'm Paolo Berenguel. Have you ever tried to build expertise across a large organization? I have been doing this for over 2 years, and I will share in this talk what worked well, what didn't work really well, and what are the pitfalls.
Hi, my name is Toyo Bali. I'll be talking about SQL Server and Postgres security model differences. This talk is for someone like me who is an accidental Postgres DBA coming from SQL Server world, and we will be comparing and contrasting the security model differences between the two database platforms.
And you can watch all of the recordings from Livestream 1 that you've seen the reel for. It happened yesterday, and you can watch it all recorded online and relive the experience or see it for the first time if you missed it.
Definitely going to be checking out a few of those because
Yeah, and I think this is the wrap, Thomas.
Yeah, we did it.
We did it. Thank you, everybody who joined us, wherever you are in the world. If you're staying up late to watch or starting the day with coffee with us, thank you for being here. Looking forward for the next day and meeting you all in the hallway track throughout the other live streams.
All right. Thanks very much to all the speakers.
Thank you. Bye.